Hello everyone, welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert science. I'm Ken Hansen, Associate Professor in the Department of Chemistry and Biochemistry at Florida State University. I'm a photochemist / photophysicist. I shine light on molecules and want to know where that light energy goes, whether it be move electrons or energy transfer, make and break bonds, and ultimately hopefully do something useful with that energy transfer events. But more importantly, joining me today is Dr. Hitesh Changlani. Hitesh, if you wouldn't mind introducing yourself.
Hi, Ken. Yeah, hi, everyone. I'm Hitesh Changlani. I'm an assistant professor. I just recently got tenure at FSU.
Congratulations.
Thank you so much. And I've been here since 2018. I came to the US in 2007 as a grad student. I was at Cornell, which is in upstate New York. It gets really cold there. And I'm originally from India. I was born and brought up in Mumbai, which is on the west coast of India, where the weather is like Florida. And then I went for my first postdoc to University of Illinois Urbana-Champaign, south of Chicago, for those of you familiar with that area. Yeah. And then I went to Johns Hopkins in Baltimore. It's famous for its med school, but the physics program is also very good. Mm-hmm. Then I came as an assistant professor here.
So what's your research expertise?
So I work on quantum systems of many particles. I'm a theorist, and you might say, you just wave your hands. Well, that's not true. I actually do a lot of computer calculations of electrons in all sorts of material settings, superconductors, magnets, and we develop a lot of computer algorithms to study these systems in different conditions. And some of these conditions involve large magnetic fields. So yes, that is primarily the focus, to understand how do electrons, which are your everyday materials, behave in different circumstances from the point of view of theory.
So what do you typically teach?
So when I came to FSU, I taught a few undergraduate courses, but primarily I've been teaching graduate courses, and that involves like quantum mechanics A and B, graduate quantum mechanics A and B. Which is, we basically say, why Newtonian mechanics is all wrong, and why at certain scales. That's right. That's subatomic scales. And then our undergrads come in and they're like, graduate students come in and they're like, everything I learned is wrong. Well, that's not true. As Ken said, there's a regime of validity where these things are very useful.
It's good enough.
Yes. That's right.
All right. Equally important. What game are we starting with?
We're starting with Super Mario Brothers. It's a game I played as a kid. I've not played video games in a very long time. So Ken was generous and let me start with Super Mario Brothers.
No worries. It's whatever you want to play. Yeah. All right, let's do it. Go ahead and press start.
Okay, I'll press
start again.
Yes.
So yeah, we're jumping back to 1985, ladies and gentlemen. Yeah. The good old days of gaming. So you'd say it's been 30 years, 35 years?
Yeah, well, I'm not that old. But yeah, close to 30 years that I've not played these games. Yeah.
The Dark Angel, welcome to the stream. Thank you for joining. Thank you for following us. We always appreciate a new follow. You'll get notifications about future streams, but also you get some internet points that you're going to gamble on predictions that we do later. Thank you for joining us. King Willie, welcome back. It's always a pleasure to see you coming out of the woodwork for the physicist, which is exciting. But it's coming back to you, right?
It's absolutely coming back to me. I played badly then. I played badly now.
So before we start the stream, I have the game running while I set up the camera and the microphone and all that stuff. Yeah. And as soon as Hitesh heard the song, he was like, dun, 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 dun.
It's so true. It's just wired in you.
It's arguably one of the most famous songs on earth. No joke about that. Which is awesome. But yeah, King Willie, welcome to the stream. Dark Angel, thank you for joining us. We'll open up to questions in a little bit. We like to let our guests settle in a little bit, playing some gameplay.
Sure.
We'll let you beat the first level at least.
I got a flag.
I guess I'll have to let me know if the volume's low or anything. I can turn it up or turn it down. Just let me know. All right. One level down.
No, awesome.
What was it? I think 64 levels in this game. But we have infinite lives. Pretty much a God code going on.
And we have a few hours to be.
Yeah, exactly. You can enjoy your time playing some Mario, reminiscing days of old. You think you're going to start gaming again when your kid's old enough?
I think so. I'm already getting, I think, a little addicted.
That's what's nice. These emulators are really good.
Yeah, that's right.
Like you can play this browser now.
I actually looked up some research before coming here. It says video games are very good for your mental health, and I was very positively surprised by that. I was like, some people get a little addicted, but I think this is a healthy dose of it might be good. Yes.
Yeah. Well, there's like treating PTSD and coping with depression and all sorts of stuff. Yeah.
That's awesome. Yeah.
Well, not just that, but like dexterous skill as well. With
Absolutely, yeah. Hand-eye coordination,
Yeah.
everything. Yeah, absolutely.
Well, it depends on the nature of the game you're playing. I mean, puzzle games and things like that.
Well, that's
Like-
absolutely right.
My 7-year-old's playing Mario now, so
Oh, wow.
I'm enjoying that. Starting on easy levels and going from there.
Nice. Very nice.
All right, Hitesh, you've settled in.
Yes, absolutely.
You're reasonably well ready to go. So I'm going to start with a hard question. No, I'm
Yes.
just kidding.
No problem.
We'll start easy. We'll start with down the drain. We'll start with the classic one. Like, obviously, most of us take very winding roads to get where we are, but there are certain events that you can remember back to when it was like, hey, I might like sciences. Hey, I might like physics. And so you've recounted several of your major locations.
That's right.
What were the steps along the way that helped you decide, I'm going to major in this, I'm going to go to grad school in this, so on and so forth?
Right. So that's a great question. I think there are various key events that happened. So when I was a young kid, we didn't have really the internet, and we had these books called Young Scientists. I think they're probably published, maybe no longer published in the US, but they gave some ideas for making things like a pinhole camera and so on. So I got extremely intrigued, and also things like electronics, like basic, how do you make a circuit or something very basic like that. So I was very intrigued, and maybe I was a bit of oddball, and people were like, why are you playing around with these things? But then I realized actually my key interest is more in the abstract and theoretical aspects. So I got, I guess, very good grades in math. So I was like, oh, wow, maybe I have this very abstract way of thinking, and which is actually the sort of key skill set you need to understand a completely abstract theory like quantum mechanics. It's like, it just violates everything that you think that you know about the world, and you're like, you got to revisit everything
That's
from
the challenging
scratch.
part, right? There's no classical analogy. It's like you have to imagine it.
Absolutely. So this is the kind of thing that really. So I think when I went to my undergraduate, which was at the Indian Institute of Technology in Bombay, basically it's very standard for Indian parents to be like, why don't you do engineering, because engineering will land you a job. No, what about physics? So I achieved some sort of I achieved some sort of compromise, and I took up a program in engineering physics, which is like the equivalent of an applied physics program here. And so the first 2 years I was doing a lot of microcontrollers, analog circuits, digital circuits, all sorts of things. And then the last 2 years were more like quantum mechanics and advanced E&M and astrophysics. So I gradually transitioned into physics. It was not like, I want to be a physicist from day one. A lot of people, our senior colleagues say, they saw, this the launch of the space satellites, etc., which made them go into physics. But for me, it was a more gradual process, I would say, and for sure, yeah. So, and then even then, I would say I was undecided. But I think in the last year of my undergrad, which is the 4th year of my undergrad, I basically said, I want to do something like computational physics, which like has a very strong mathematical component. It has quantum mechanics in it, and so I basically went that route. Yes. It was not like I'm going to do this for the rest of my life. No, it was more gradual.
And so you decided on theoretical physics, you applied to grad programs.
That's right.
And then from there, deciding your flavor of theoretical physics, because you could do high energy particle physics, astrophysics. You chose condensed matter.
Absolutely right. So actually, our undergraduate program had many courses which were electives, and I got a good flavor of what was going on in particle physics. And I had a lot of friends who were reading books by like Barton Zweiback, who wrote a book on string theory and so on. So I realized that I like abstract things, but at the end of it, I also want to see maybe some tabletop experiment that probably realizes what I'm thinking about and so on. So I quickly figured that maybe particle physics is not the thing for me, because it's at a very advanced stage. You got to go to Geneva, you got to go to CERN, you got to do all these big experiments to see. You got to smash particles at very high energies. So for me, I was
that was close. That was a good move, though.
yeah. So for me, it became very natural to lean towards condensed matter physics, even though condensed matter physics is, I would say, it's all around us. It's there everywhere. It's in our iPhones, it's in our laptops, everything. But I'd say it's maybe less attractive, because it's less fundamental in a sense. But I actually beg to disagree. I mean, once you stay in the field for long enough, you realize that there's very, very nice things going on there.
Yeah, I mean, it's a challenge, though, because chemistry has the same issue, because it's a very applied science, right?
Absolutely.
It's a physical reality, and it doesn't have the sexiness of astrophysics, right?
Absolutely, right.
When you think about the popularizers, it's a lot of, Carl Sagan's, but you also have Richard Feynman's, who is,
absolutely,
So it's a mixed bag, I guess.
Yes.
All right, so then you went to grad school, you specialized in condensed matter. What flavor? What problems were you working on?
Yes, so I started off actually working with the chemist, theoretical chemist, and he basically worked on quantum chemistry, so things that your colleague in the chemistry department does, Eugene Depens. And actually I found that there are many common things which are just given different labels, different names in physics versus chemistry.
Yep.
So, so I started working in more computational physics, developing computer algorithms, as I mentioned. There's a standard theory which everyone uses. Maybe many people who have encountered physics may have even heard of it. It's called density functional theory, and won a Nobel Prize in 1998 for Walter Kohn, was actually a physicist, but he won a Nobel Prize in chemistry. And the other one was John Pople. And then the DFT is a workhorse for density functional theory, is a workhorse for many, many things. Lots of applications, drug discovery, and protein folding, name what you may. If you want a good understanding of materials, you need to have a good background in density functional theory. But what we have realized since the 1980s is that there are a class of compounds, there's a class of materials which conduct electricity at very high temperature. So they're called superconductors, and they cannot be described by density functional theory. So that's spawned an entire new field of systems called strongly correlated systems. It turns out many molecules, things that Eugene studies, for example, like the methane molecule, is also actually very, very strongly correlated. So it turns out that even though DFT was such a useful, widely applicable theory, there was a problem that showed up in the 80s that just was not ideally suited for DFT. So this is something that has spawned many, many new directions. Sorry.
Firewall was your arch nemesis. So I'll give you a hint. If you hold the B button, you can run faster. It gives you a higher jump and moves faster.
That's right. Yeah, I'm thinking about DFT and quantum chemistry.
It's a good description, though. Especially the strongly correlated.
Yes, absolutely.
So DFT can't deal with Cooper pairs and
absolutely
conductivity and related phenomena.
That's absolutely right.
And that's just the nature of the method, right?
That's absolutely right.
Electrons independently-ish.
Yes, absolutely. Yes, so DFT is some sort of what we call mean field theory, but we need to do better than mean field to understand certain kinds of superconductors.
Yeah.
And it's still an unsolved problem. I would say there's a lot going on. I think one really needs some input from chemistry and physics. We maybe need the departments to be a little bit closer to solve these problems. Yeah.
We've talked about this. We need an agreement where we can steal each other's students. That would be a good start.
Absolutely.
And joint appointments and whatnot.
Absolutely. Oops. Yeah. I am struggling with this level.
No worries. I think the Quantum Sciences Institute is a good step in that direction.
Absolutely, Ken. I think that's, I really admire Mike Shatruk, our colleague, and Steve Hill for taking this initiative. I think this is a awesome step in the right direction.
And we're hiring. And how many are you guys hiring?
We've hired, just happened today, we hired one junior person, and they just accepted.
Oh, wow. Congratulations.
Thank you. Yeah, so I was actually the chair of that committee, and spent a lot of sleepless nights.
But you won. You did it.
Yeah.
Totally worth it.
Yes, absolutely. And I mean, looking at this entire process, I cannot believe that I got a job here. Like,
Isn't it crazy?
it's just crazy. There's just so many variables to get things working, and
You guys have no idea how much just like timing and luck and circumstance, and even if you're the best, if you don't fit or somebody doesn't like you for some arbitrary reason,
absolutely.
it's insane.
Yeah. So I have absolutely no idea, and I'm blissfully unaware, and I shall remain blissfully unaware for many years to come.
Now
I
you have
hope.
tenure, so you're set. All right, Huddle Puppy, welcome back.
Oh,
This subject is right down my alley because I have a theoretical degree in physics.
awesome, Cuddle Puppy. Awesome.
No, theoretical degree, as in a non-existent degree.
I didn't have degree in theoretical physics.
I love when a chemistry presenter is like, "Oh, my theoretical friends." No, they're real friends, but they do theory. They're not just on paper. Cuddle Puppy, welcome back. It's always a pleasure. All right, so when you started your independent career, you were saying, what problems do I want to go after?
Right.
And you came to FSU, presumably MagLab was on your mind. Superconductivity was an obvious choice.
Yes.
What guided those decisions?
So actually, even those, as I mentioned, that this whole field of strongly correlated physics started with high temperature superconductors. We've realized that there is far more interesting behavior that can happen just because these electrons are doing things. They're kind of united, right? They're kind of entangled with one another, if you like.
Mm-hmm.
What one is doing is not independent of what the other one is doing. And as we just said, density function theory works well when they are kind of doing independent things. But here, if Ken's wearing orange, I'm wearing blue, and we always decide to wear kind of opposite colors. He wears a bright color, I wear a darker one. Well, then I need a better theory, and that's the essence. And so it's not only superconductors that fall into this category. From high school physics, we know solid, liquid, gas, but that's what many atoms do together. But if you ask, okay, what can electrons do with one another, or what can they do together? Actually, electrons can also form a solid, an electron solid, right? So you have a periodic arrangement of electrons. You'd say that's an electron solid. Just like a periodic arrangement of H2O molecules is ice, periodic arrangement of electrons can give you something called a Wigner solid, or just a valence bond solid. These are just names, but the essential idea is the same as what you've encountered in everyday life. And it then turns out that, can electrons form a liquid? And sure enough, yes, electrons can also form a liquid. Then you can ask, can the spins of the electrons form a liquid? And it turns out, yes, that is also possible. So that has been one key endeavor that I have pursued, the search for what we call a quantum spin liquid. And this is something that we look for in certain kinds of magnetic materials. You can ask, okay, I spoke about solid and liquid. What about gas? Yes, and electrons. You guessed it right. Electrons can also behave like gases. So this search for these phases of matter has been
time.
Oh,
There's the clock.
Yeah.
I'll give you some time to focus on this.
No problem. I'm not able to. Yeah. I guess I'm not very good at multitasking.
This is also the hardest level you've faced so far.
Oh.
No worries. If you want, I can get you a mushroom at some point. Want to play some God mode.
I'm gonna just try to run.
Theoretical degree. I like that.
And it's I need to jump higher. Okay, I'm struggling.
Yeah, no worries. I'll let you focus on gaming. It's non-trivial to do both of these simultaneously.
Yeah, absolutely. It's fun. It's fun.
What was your most nervous part about tonight? The gaming or talking science?
I'm not nervous. I'm enjoying it. It's okay if well, the gaming part. The gaming part, yeah, for sure. Yeah.
Yeah, so I send my guests the email saying, do you want to play video games? You also have the YouTube video if you want to take a look.
Yeah.
But it's something else to sit down and play while doing this.
Absolutely.
Having not played in,
that's right.
a couple decades.
Right. Okay, I
like it. All right, so we got spin liquids, you have conductivity.
Yes.
Is there anything else you're interested in? Anything?
Oh, absolutely. We are interested in also creating artificial materials. So everything we spoke about was like, okay, naturally existing materials. But you can ask, can I take layers of graphene, which we said is actually, it was actually created with Scotch tape and, there was yes. Oh, yes.
That's fine. We'll save it for later.
We'll save it for later. We can take layers of graphene and we can ask, can we realize, what's happening here?
Bowser. Yep. So you can go under or you can go over.
Oh,
that's good though. You got to the end.
Okay, I got to the end. Well, there's been a big push as I was saying, in the study of graphene, where you can take different layers of graphene and you can basically twist them relative to one another, and you can form what is called as a Moire pattern, which is that you create what is called a super lattice. So you basically have electrons which are actually very, very hot in a real material. But when it comes to graphene, you can you can cool down these electrons by basically taking two layers of graphene and twisting them relative to one another. So that is actually a very new idea, and people have realized superconductivity, people have realized Wigner solidity, people are claiming that they have found what we call non-Fermi liquidity.
So
all of these things.
Envision this. This is like taking two ribbons on top of each other and twisting them together.
Absolutely, twisting them relative to one another.
Really?
So the thing is that you basically create an emergent super lattice, because there's a mismatch, there's an angular mismatch, and that basically creates a new potential for the electrons. And so that is one of the biggest things that has happened in condensed matter physics, I would say, over the last 5 years. And it's rejuvenated a lot of questions about other things.
That was good.
About other things that people in our community study. For example, you can take what is called a two-dimensional electron gas. You can say, okay, we'll confine electrons to two dimensions, like you can use gallium arsenide layers, and you can also subject them to high magnetic fields. And then you can ask, okay, how do these things respond to a high magnetic field, or what are their transport properties, how do they conduct electricity, and so on. And that basically gave rise to the study of what is called as the quantum Hall effect, for which Bob Laughlin actually won a Nobel Prize in 1998. And you can actually see things like fractionalization. So this sounds more exotic than it is. So you can say, okay, I mean, I flip a spin, or I have a spin that's pointing up, for those of you who've done basic quantum mechanics, and you flip a spin from up to down, and you say, oh, well, I put some unit of angular momentum, I put some energy into the system, so that made the spin flip. But you can say, can I split the electron? Can I split this electron into two pieces? Well, you cannot really do it, but if you think of many electrons collectively doing many things, well, then you can say that emergent, that means that effectively, that a new law or a new scale or new particle has emerged, which behaves like half an electron, or behaves like 1/3 of an electron. So we are not saying, we're cutting up an electron into three. You're actually seeing the effect of many electrons acting as if they are 1/3, as if they have 1/3 the charge of what you normally would have. So that's the idea of fractionalization, which is actually a very big theme in condensed matter physics. And as I was telling you, these layers of graphene also actually realize these phases, which were seen earlier in electron gases that the people study at the Mag Lab. But they've also started studying it in the context of graphene.
How do they experimentally do electron gases?
So you take basically gallium arsenide, and you basically have you have a confining potential in one direction. So you basically don't let the electrons leak out in the other direction. So people basically realize electron gas is at the interface of 2-3-dimensional materials.
I see.
That is typically how you do surface physics. So
I'm surrounded with an insulator of some kind.
Absolutely. Yeah. That's absolutely right. Yes. Yeah. What am I doing here?
I'll get you a mushroom after this. We'll make your life easier. I don't want you to play the same level over and over again.
Oh God.
All right.
Sorry about that. Yeah.
No worries. I'll try to get you a mushroom. We'll see how this goes.
I'm struggling.
Nope.
Oh, awesome. We became bigger. Okay.
There you go.
Okay, awesome.
All right. That should make your life easier.
Thank you. Much appreciated.
All right, yeah, so we've settled in. We're playing some Mario on level 1-4. Our guest today, Dr. Hitesh Changlani. He's an expert in condensed matter theoretical physics, not theoretical condensed matter physics, but condensed matter theoretical physics.
Yes.
He's worried about or interested in many electrons and how they interact in very unique ways that can't be described by classical physics, and how that manifests as things like superconductivity, magnetism, entanglement, quantum information applications, spin liquids, all sorts of crazy stuff. That's what's on your website. Physics of disorder.
Absolutely, yes.
Just
yes.
something non-intuitive, but yeah, to trace it back to our original conversation, like, yeah, there's a lot of things that classical physics describes really well. Shooting a cannonball, shooting a free throw, throwing a baseball.
Oh, wow.
But as soon as things get small or very big, all of a sudden physics breaks, and you're on the very small end of things.
That's absolutely right. Yes, absolutely right. And there are people certainly working on the interface of the very small, which is, few atom systems or solid of few electrons, comprised of few electrons, which is what we can actually afford to do on our computers. But this thing about graphene that I mentioned, it actually also bridges with what we call mesoscopic physics. I mean, physics on the scale of nanometers or multiple nanometers, which are very important for your everyday devices as well. I mean, your transistors are hitting the nanometer regime. So what happens to quantum effect? What quantum effects contribute at those scales? That is also an interesting question that many people in our community answer or try to address, because we have Moore's law, and Moore's law is saying that, okay, we can double the number of transistors on a particular chip, but that we're hitting the limits of that because nature has set some limits. We cannot go infinitely small. We cannot keep doing that forever, because eventually we're going to hit the nanometer limit, which we already have hit. So we have to worry about quantum effects at that scale.
Misadventures in Astro, welcome back. Thank you for joining him. I'm assuming you're an astrophysicist and or astrobiologist, so welcome back to the stream. Thank you for joining us. If you have questions for Hitesh, he's happy to answer them.
So the thing about, I don't know if there's a question, but the thing about these crazy things, as theorists, you see that you have to be a little bit crazy, is what I would say, because you got to imagine things that are just so non-intuitive, you don't see them in everyday life. So you got to be a little bit high in some sense. But the point I want to make is that a lot of these non-intuitive things become intuitive for the next generation, right? Yeah, so you take, for example, Bose-Einstein condensation, which is that if you take many bosons, so, it turns out that particles in nature come in two varieties. Press the B. They come in either variety of fermions or bosons. And fermions basically hate each other. Like they obey something called the Pauli exclusion principle, which some of you may have seen in chemistry, that you cannot have more than 2 electrons in the lowest energy state of hydrogen or something like that. And it turns out that bosons don't have any such restriction. So that has a deep. How do I go higher? That has a
time your jump button.
It's a B or A?
A button.
Uh-oh, I lost time.
No worries. Misadventures. So just an amateur astronomer that works in the commercial space industry.
I see.
Oh, that's fun. So over the spring break, my wife and I took our daughters to the Kennedy Space Center.
Right.
I don't know if you've been there, but it's pretty spectacular.
I have not been there. Awesome.
It's really fun. I mean, seeing the space program, the history, but also they have a lot of commercial space related things. So SpaceX, and I can't remember Bezos. What was his company's name? Blue Origin.
Blue Origin or something like that.
Yeah. So we got to see their exhibits and their various different takeoffs. Blue Origin, there we go.
I see.
Yeah. So that was pretty fun. It's awesome. Definitely worth the trip. My daughters are too young to appreciate it.
This is Cape Canaveral, right?
Yep.
Okay, nice.
So the daughters are a little too young at 7 and 4 to appreciate it,
Right.
but I loved it. I had a great time.
Nice.
There. So I enjoyed that.
Is that where NASA also launches all the satellites?
Yeah,
I think
yeah,
that's
yeah.
true, right? Cape Canaveral, and also SpaceX, as you said. Yes.
Yep. So they basically rent out space, I guess, to other commercial entities.
I see.
But yeah, it was really cool because you got to see there's a lot of history there, like the Saturn program and the,
Nice.
things like that. Which is way sexier than condensed matter physics. You don't have an exhibit. That's what we have to compete with, recruiting students.
Absolutely. Yeah. It's in your iPhone, and
Yeah, exactly. You owe us. Giant green shell. But yeah, you guys
Blue
have
Origin. I
questions?
think they got it right. Yeah, Blue Origin. Yes.
Yeah, that was fun. We saw them transporting, I don't know which rocket it was. It was something for Blue Origin actually on the road. They stopped traffic and
I see.
yeah,
Wow.
you get to see them drive by and everything, which is really cool.
So, what do you think of the future of space exploration? Just your 2 cents on this.
Man, I don't know. I'm excited about colonizing the moon just out of the scientific exercise behind it.
Right.
The engineering feat that's required to make that happen is profound.
Profound, absolutely.
I would love to see us do that. And it's one of those, the Kennedy quote, we don't do it because it's easy, we do it because it's hard.
Absolutely. I love that quote. Yeah.
And it's one of those, there are theoretically ways to make water out of, moon material kind of thing.
Oh, I didn't know that. I just thought moon has some resource for water, but is that?
So it has some, supposedly some natural water cavities or something like that, but one of the arguments is you can take, it's a lot of metal oxides, right, or silicon oxides, and if you can take the oxygen from that and combine it with hydrogen, you make water.
I see.
And so it's a question of how you might do that, and is it worthwhile?
I see.
Can you develop materials?
I see.
Yeah.
I see. So, I mean, regarding colonizing the moon, what do you think about colonizing Mars, which is what the more ambitious program was, right? They wanted a one-way ticket to Mars. Right?
That's exactly.
But then a lot of people signed up, apparently. And I was like,
man,
that doesn't sound very good.
That takes a personality type.
Absolutely.
We're glad those people exist. I'm not one of them.
Not at all.
I don't think I could handle the stress of launching. That is an experience in itself. I don't know. I'm excited for others to try. If they're successful, so be it.
You don't want to contribute to humanity's quest to colonize Mars? No. Okay.
I've never had that drive. I don't look to the stars and long for involvement. But anyway, we're a half hour in. We should do a prediction right now. Let's do I'm going to suggest the anti-electron.
Sure, absolutely.
I think that's when you talked about imagining.
Yeah, I think that's very important for a theorist.
All right, ladies and gentlemen, so we do predictions on stream, but unlike most streams on Twitch, we don't do predictions for video game related things. We do science questions. So I asked Hitesh about a week ago, hey, can you come up with 5 or 6 questions related to your expertise? 2 options that you could ask the audience. And so we're putting you guys on the spot to answer this question. And so you're going to use imaginary internet points, and you're going to bet on which one of these answers is correct to the question. And so the question that's coming up is, the anti-electron, also known as a positron, was first seen in experiment or theory? Was it predicted first, or did they see experimental evidence for something and then explain it with theory? And I love this question because this goes back to every fundamental particle, predict things, even back to the origins of the word atom, right? Atomos was predicted theoretically before experiment. And so this is a really fun one. Was anti-electron first seen in theory or experiment? Did we predict it, or did we see something that might be described as a positron? And so, yeah, if you guys aren't following us, click the follow button. It'll give you 300 standard internet units. They're useless outside this channel, but they do get you guys. You can make us take a drink. You can request a factoid. You can unlock emotes. So yeah, click that follow button. And then after that, click the predict button at the top of chat and make your prediction about whether the anti-electron, the positron, was first seen in theory or experiment first. And we have a 50-50 theory versus experiment right now. Is there anything you want to add without giving away too much? I think it's pretty straightforward.
Well, there's a connection to FSU. I'll just add that.
You know that connection.
If you know that connection, you probably know the answer.
Yeah. But note your Ask a Scientist Gaming honor policy. You can't cheat and Google the answer. You have to know it from your knowledge. What you know of Hitesh. Make your best guess. Which one is it? Theory or experiment? Put your predictions in there now. If you haven't predicted for, click the predict button. It's kind of fun. Again, these internet units are absolutely useless, but you can use your pride if you get it correct. So that's more important. Getting right answers feels good. Releases those endorphins.
Absolutely.
That's mostly why we do what we do. It's the momentary rush of getting something slightly right.
So true. That's so true. We don't really, at least I speak for myself as a theorist, we don't really think of all these applications and so on right away. I mean, they're very important. Of course, they keep science alive. But, just the joy of figuring things out, that's just so important. And so, yeah.
All right, Hitesh, what's the answer? Experiment or theory? When did we...
Oh, what do you guess? I'm a theorist.
So the answer is theory?
It is theory.
Theory is the answer. Congratulations, whoever bet big on that one. Looks like JTP goes big with 1,800 standard energy units. Congratulations, you got a 1.06 to 1 payout because you bet so big one way. Congratulations. They predicted the positron theoretically first.
Absolutely. And the connection to FSU is that it was predicted by Dirac, and Dirac was a scientist, was a faculty here in the later years of his life. So Dirac won a Nobel Prize for this stuff. And just to give you some context, the electron was discovered first in about 1897, so 130 years ago. And then Dirac basically was trying to write down some equations that describe electrons. Found that his equations actually also predicted something which has the opposite sign of charge. And it wasn't quite a proton, right? So for a long time he thought, oh, well, I'm just looking at a proton here in my equations. Turns out that was not the case. Its equations actually predicted that there is an anti-electron, an electron with a positive charge, otherwise the same, has the same mass, but has a positive charge. And you won't believe it that positrons are now used in all sorts of medical imaging applications as well. So it's one PET scan. So it's one of those things that you really have to give credit to a theorist who predicted antimatter, the first kind of antimatter.
And if I remember correctly, he didn't necessarily believe it.
He didn't believe it.
And that's hard, right? For a theoretician, it's like, is this a manifestation of the math that's wrong, or is it a physical reality?
Absolutely. As I said, for a long time, he believed that he was looking at a proton. But look, a proton is almost 2,000 times heavier than an electron. So the math, there was just no way to salvage it. There had to be something. Do I go up here?
Yeah, so press the swim button multiple times. There you go.
The A.
Yeah, press it a bunch.
I see.
That'll get you up.
I see. Yeah, so you got to trust the math, right? As a theorist, you got to trust the math because people are probably going to ridicule you. Oh, this sounds really crazy. This cannot happen, and so on. But it happened. There are examples of where it happened. As I told you, positron is one, but Bose-Einstein condensation is another. So. Yeah.
Are there examples that go the other way, where people are sure it's going to manifest?
All the time.
Like string theory is, as far as we know,
all the time. Right? There are more wrong predictions than right ones.
So maybe balance your belief in the math?
Yeah, absolutely.
Like in retrospect, it's easy to look back and say how right he was, but
that's right.
He could have been completely wrong. So experimentally, do you know when we measured a positron the first time?
Yes, thank you. So Carl Anderson, who was at Caltech, I believe detected it in 1932, and Dirac went to the Nobel ceremony in 1933, and Carl Anderson went in 1936. So
that's amazing.
Yeah.
How did he detect a positron? I'm not familiar with this.
Well, I think he was using a cloud chamber, and he was just looking at which plate. So you can basically track the particles and see which direction. The sign, the polarity of the plates, right? And then you figure out the
charge,
the charge from the trajectory that these particles take.
Yeah.
So that's how he figured it out. Yeah.
Those cloud chambers are so cool. Have you seen one of these in person?
Oh, absolutely. We do a demo here. It's called the Circus of Physics. It's an annual event that we have, and so we basically yes, I have actually seen a small scale version of this.
Yeah, you guys make it for that, or that somebody brings it in?
Well, we have actually a very good staff here who basically he just has it in his lab, and
awesome.
we basically just use it.
Man, are those commercially available? I'd love to own a cloud chamber.
That part I'm not sure.
Just put a banana on it and see what happens. Because it's just, for those of you who aren't familiar, you basically fill a chamber with gas that's just barely above the threshold for condensation, where it turns from gas to liquid.
Right.
And so even the perturbation of like a neutrino, not a neutrino, but an alpha particle, an electron, a positron, any of those guys, they shoot off and they'll actually make a trail, a cloud trail through this chamber. And so you can literally see, and there's a difference between beta decay and alpha decay, and it's so cool. It's just, you see a wake behind these high energy particles moving super fast. It's just such a cool creation.
Yeah, absolutely.
I didn't know you guys have one. That's cool.
It's a very small scale one, but yeah, we have one.
There's a guy on TikTok that does live streams of the smoke chamber. That's pretty cool. You know, if you're gonna use TikTok for anything, it might as well be that. Man, I bet we could do a Twitch stream of a cloud chamber. Just like
I think that would be a very good idea.
Yeah, it's like a screensaver for your computer.
Or just come to the Circus of Physics.
My favorite live stream is, have you heard of this, the 10th Watch? It's a viscosity experiment.
Oh, okay.
The world record for the longest running experiment ever. And it's a website. So what they did is, oh man, I don't remember the guy's name, but it was, 100 something years ago, he basically put tar pitch inside a funnel, and then he cut the bottom of the funnel. And tar pitch has a non-zero viscosity, right? So it moves very slowly. So every 10 years or so, a drop of pitch falls.
Oh, wow.
And so there's a live stream on the internet watching it fall. And we're like 10 years away from the next drop.
Oh, wow.
So you see nothing on our time scale, but it is falling.
It's falling. It's a good measure of time itself. It's
an hourglass. Decade glass? I don't know. That's a fun experiment.
So, Ken, I want to know more about you. What brought you to FSU?
So I'm a photochemist, and so I've done grad school. I did OLED technology, so it's the molecules that go into organic light emitting diodes and organic photovoltaics. Made a bunch of molecules for that. In grad school, I did a catalysis, but a lot of spectroscopy, so time resolved emission, transient absorption, watching evolution of species after you shine light on them.
Yes.
And then when I was applying for jobs, it was like I'm a photochemist. Like I use light to drive everything, and so FSU is obviously a legendary place for that. Like this is the house that Kasha built, kind of thing. Michael Kasha's rule. He came up with the N to pi star, pi to pi star, all that transition nomenclature.
I see.
He's the one that discovered singlet oxygen. So he's an icon in the field, and so like when FSU responded to my application, I'm like, yes, I want this place.
Very nice.
And so now that I'm here, it's like half our faculty do light-driven something chemistry.
That's very interesting, because actually light-driven phenomena are becoming very important in condensed matter physics as well. I mean, the hope is that one can manipulate materials which are not superconducting into becoming superconducting with the help of light. So trying to steer materials towards achieving some sort of metastable state.
Oh, interesting.
Yeah, so that's called, there's a whole field called Floquet engineering. I don't know if you
No, I've not heard of that.
Yeah, all these French names have come back into fashion. Gaston Floquet. I mean,
French? It's after individuals?
Yeah, it's named after Floquet, Gaston Floquet.
Okay.
I'm sure I'm butchering the French pronunciation. But again, he was doing this abstract mathematical things, trying to look at things in the time domain. And now it's become relevant again, because people are like, okay, can we shine light, which is a time-dependent electromagnetic pulse, and you see how our materials respond to light, and can we engineer phases that wouldn't normally exist. So I think that's you touched a nerve there.
Yeah. Well, that's why I'm kind of involved in the quantum informations push, right? Because there's a non-trivial amount of like using light as read-write for these qubits and things like that. And so,
Absolutely.
Yeah, one of my big things is putting molecules together on surfaces, like assembling them in unique ways.
I see.
And so basically, when you think about a lot of this molecular QIS stuff, it's like put a radical species with an excited state species with a charge separation interface, and all of a sudden you have a read-write mechanism.
I see.
And so I haven't dove deep into it yet. I haven't started like making devices, but that's where I'm intrigued.
Oh wow, interesting.
So I talked to Mike and Eugene, and how can I be of help in assembling molecules in unique ways?
Absolutely.
Oh, Misadventures has a follow-up.
Yes.
Chaosnick68 on TikTok. He's an astronomer professor, but on cloudy days he does the cloud chamber. So, Hitesh, I don't know how familiar you are with Twitch in general. Have you seen it
I'm
before?
not very familiar. But you can tell me a little bit about it.
So it got its rise to fame for people playing video games, right? Like playing video games on stream, which is why we're doing it here.
Yes,
but on the side of that, there's people that are like education streamers, right? So they'll do their math office hours or something, or they'll like do physics lectures on Twitch, or whatever topical area. So there's this science and technology subcategory where people are just hanging out. So
very nice, yeah.
And TikTok has a lot of famous science people as well.
I see.
But you got to cut through a lot of BS and like non-science and pseudoscience. But there's some really good people out there.
So I'm very glad that people are so interested in science and enjoying video games and asking scientific questions. That's a very nice. I really like this concept. I'm warming up to it. I'm not very good at the video game part, as you can see.
On paper, it's a lot of fun. Ooze Goober, thank you for the follow. Thank you for joining us. If you have questions for Hitesh, he's happy to answer them. Condensed matter physics, theoretical physics, many electron systems. Throw your questions in chat. We're happy to answer them. Ooze Goober. That's a spectacular name. Thank you. So which cataclysmic theory was more plausible? The Large Hadron Collider, Large Hadron Collider creating a black hole, or the atomic bomb igniting the atmosphere? So there was a non-zero probability that the Large Hadron Collider would create a black hole, if I'm not mistaken.
It's a little bit outside my domain, but I think that those were mostly unfounded rumors that's going to create any serious trouble. Maybe you have a tiny black hole that's very, very, very short-lived.
Yeah.
Sure, you have a burst of energy that you produce, but whether that was going to destroy the world, I don't think so. I think we're going to probably destroy ourselves with nuclear stuff or atomic bombs. Well before that ever happens.
Yeah, I think Rachel got asked that question, actually. Because if you do the math, you can make black holes spontaneously through high-energy collisions, but it's not going to start sucking in chairs or anything from the room. It's got to be very, very small. Why would the black hole be unstable?
So these are very good questions. It turns out that, in quantum mechanics, you can produce things temporarily, and they basically decay, because they have a very short lifetime. Now, it turns out that everyday things like proton, when it has a lifetime of even longer than the life of the universe, it's just 10 to the 31. So the thing is, it depends a little bit on the rules of quantum mechanics. It depends a little bit on what quantum processes are creating these particles. We call them virtual particles. They exist for very, very short times, and then they go away. Why should something be stable or not stable? So you can ask the same thing about atoms, right? You say I take a hydrogen atom and I shine light like Ken does. You say why does that not stay where I prepared it? And the reason is that it's also interacting with the vacuum, which it turns out is not such a quiet place. Vacuum basically has what we call vacuum fluctuation. So even though we might think, vacuum, there's no particles, there's actually a lot going on in the vacuum. And so things can spontaneously emit energy, spontaneously lose energy by interaction with other particles, even though you might think there are no particles out there, they're actually part of the vacuum. And so this is the number one reason for why your flashlight works. Actually, it's called spontaneous emission. In fact, it turns out, I'm just teaching this to my graduate students, it's much harder to explain why your flashlight works, and it's much easier to explain why your lasers work. So lasers are a very focused beam of light, and that's because in spontaneous emission, you got to worry about things called vacuum fluctuations, things that that the vacuum is not a quiet place, and all your particles are interacting with the vacuum, which is where they lose energy. So that's as a dog, my fears of vacuums are well established. Yeah, so that's the reason why a black hole might be unstable. But really, one has to do the calculations and have a theory for really provably proving something like this. Yes.
Yeah, so I had to look up the atomic bomb igniting the atmosphere. I wasn't familiar with that one. So like when I think ignite, I'm thinking combustion, right? And there's not enough carbon or anything in the atmosphere to do anything useful.
That's right.
But there's a tangential argument that you could potentially have some kind of nitrogen fusion of two nitrogen-14 nuclei and hydrogen nucleus in the atmosphere. I guess that's what they were describing.
Okay.
About igniting.
I don't aware of that. Yeah.
No. But that is intriguing.
That's intriguing. I didn't know of that theory.
I'm going to say that's not possible, or it's not a major concern. So if it was, we might have seen it already.
I imagine.
Man, Cuddle Puppy, where do you learn about these conspiracies? I'm curious. It's TikTok. That's where.
Oh, he said, did you really not watch Oppenheimer? Well, yeah, actually, I haven't watched it. It's one of the big regrets. I haven't watched it yet.
I haven't either. That's tragic. I watched the Barbie movie, but I haven't seen Oppenheimer yet.
I know a lot about Oppenheimer, but I have not watched the movie.
So Oppenheimer's going back in theaters, if I'm not mistaken. Right?
It is?
Yeah,
Okay.
I think they're going to put it back out because it did so well.
Yeah.
But Cuddle Puppy, I apologize. I haven't seen Oppenheimer.
I apologize as well. Oh, and
Oh, man.
I don't know what the filthy part, but science casual, yes, I do agree.
Oh, no. Ignite the atmosphere. Oh, man. Get a ticket, absolutely. Oh, thank you for the bits, Misadventure. Thank you for joining us. It's always a pleasure when we have scientists or even hobby astronomers in the audience. Man, presumably you watched the eclipse. Did you?
I did watch.
David Collins flew up to Ohio to watch it, actually.
Oh wow!
Yeah.
Well, I did see when it was at a 30 or 40% level. I unfortunately had a student in my office that time, so I had to get glasses from my colleague to watch it. But it was pretty cool. It was pretty cool. So what about you? Did you see?
No,
did you see it from?
Really, I didn't.
You did not. Okay.
Well, so. Our admissions deadline was Monday.
Oh, wow.
Right? So it's I'm in charge of graduate admissions in chemistry. So it's kind of a nightmare of a day. So I missed out on it.
Yeah.
Misadventures. I streamed the eclipse on Twitch for Arkansas. That's fun.
Oh, wow.
Misadventures. I did not know you were a streamer. I apologize for not to give you a shout out. That's really fun. Misadventures in Astro. There you go, ladies and gentlemen. We have a fellow science streamer. You guys should definitely check out Misadventures stream. Streaming eclipses, but only doing so every 20 or some years. Fun factoid, the next one I think is 2044, and it's actually going to go directly through Tallahassee.
Oh wow.
So yeah, we'll be able to see it. We'll have a good front row seat here in 2044, assuming we're still alive and the atmosphere doesn't ignite or we get sucked in by a black hole.
Lots of assumptions. You must be a theorist.
That's fair. Did you ruin your camera's sensor? That's a good way to ruin it. Yeah, that's a lot of photons. Don't point stuff at the sun. Get the neutral density filters. Yeah, a lot of light is very, very damaging. No, I have a white solar filter and do solar streaming regularly. What is a white solar filter? I'm assuming that's the hydrogen lines or something. Where's our astrophysicist?
I was looking at the chat and I lost track of Mario.
Sure, blame chat.
Easy one to
Solar
blame.
filters. That's intriguing. Sorry, this is an optics thing. I spent a lot of time with long pass, short pass, band fast, laser line filters. What is a solar filter?
Well, sort of that hates spicy food. I didn't quite get that.
That was a white person joke. We don't like spicy foods. Especially if you're British. Cuddle Puppy, you dug deep on that one. Thank you. Solar filters spectrum. I just want to see what the profile of it is.
Complicated. Oh. Wow.
Huh.
Oh.
Closer to green, I believe. Oh yeah, there's a spectrum there. It has a roughly 35 nanometers is what they let through. That's intriguing. So it blocks out everything but a certain portion of the light. That's pretty cool. Oh yeah, nanometers. So what are you thinking? Electron volts? What's your
I think in electron volts, milli-electron volts is closer to what is relevant in condensed matter, but electron volts, milli-electron volts is what we like. Yes, absolutely.
So
those days of joules are gone.
so chemistry, we're stupid because of absorption. Optical spectroscopy is in nanometers. If you do vibrational IR spectroscopy, it's in wave numbers.
Okay.
if you're measuring the energy of laser, it's in joules or watts.
If you're doing quantum chemistry, it's Hartree.
Yeah. But if you're doing electrochemistry, it's electron volts.
Okay.
So, yeah.
But that means you know how to convert it in your head, right? You can do it in your head. You don't need a Google calculator or anything like that.
So the thing is, I partition that knowledge set. So if I'm talking electrochemistry, volts and electron volts is really easy.
Right.
But I don't ever convert like nanometers. That's what we use in the optical domain. So,
I see.
Yeah, it's I don't know. It's a mess.
So where did you do your postdoc, Ken?
I did it at UNC Chapel Hill.
Oh, very nice.
So I worked for Tom Meyer, who does a lot of inorganic transition metal complexes. RuBiPi, what he's best well known for, it's this ruthenium tris bipyridine complex. It's really good for moving electrons around. People use it for catalysts and stuff like that now.
Oh, wow.
Yeah, pretty fun.
I see. Oh, wow. And did you always know you wanted to be a faculty or?
No, I didn't. I was a convoluted path. So I changed majors as an undergrad 4 different times.
Oh, wow.
So I got hurt a lot. I was in sports in high school, and sports was a big part of my life. And I went to college to do sports at St. Cloud State University, so track and field.
I see.
But I spent a lot of time with athletic trainers and physical therapists. And so I started out wanting to be an athletic trainer. And then I transitioned to exercise science because it was like, while athletic training, I'm like, sure, this is great. I learned how to tape an ankle and treat things, but I don't necessarily understand the cause. Right?
I see.
So I dove into exercise science, which dives a little deeper. You talk about vasodilation and things like that.
Yeah.
But then it was like, I took a biology class. I'm like, ooh, this dives a little deeper still.
Wow. Yeah.
And so then I transferred to biomedical science and was thinking about physical therapy. And then I took organic chemistry and I fell in love with this idea of controlling the world through its atoms. And that was like chemistry. I did an RU and that changed my life.
Very nice. Yeah, that's awesome. So you did have a eureka moment or something.
Yeah.
Where, like,
no, there were several of them, especially with athletic training. One I remember very distinctly is we were, doing, I was an athletic training class. And we'd like tape ankles, but there was also a textbook and we'd read up on things. And one of the things we talked about was ultrasound, right?
Oh, wow.
They use it in physical therapy to break up hard tissues.
Absolutely.
And so you send basically vibrations into the body, and those vibrations shake apart, scar tissue and things like that.
That's right.
But this sentence in there, and this goes back to our, solid state physics, is the way they make those vibrations is piezoelectric effect, right?
Yes.
So you put electricity through a system, and all of a sudden it vibrates. That like blew my mind. And I'm like, how does that work? And then expanding that to how do you make an ultrasound image of a baby? Well, you send those vibrations in, but then vibrations reflect back, and you can sense those through the same mechanism, but then the vibrations generate electricity. And all of that blew my mind.
Awesome.
I need to dive deep. So it was several moments like that that really just, holy crap.
Uh-oh. I see. And then where do photons come into this picture? Like, when did they come into the picture that you want to do photochemistry?
Oh
something
man,
more specific?
it was actually so when I fell in love with chemistry,
Yeah.
it was late in a spring semester. It was like March or April, and I really liked organic, and my professor was like, Ken, you're doing well at this. Like, you seem to like get this or really appreciate it. He's like, you should try doing an RU program. I'm like, what the hell is that?
Right.
And he's like, well, you apply and you do summer research somewhere, and I didn't know this existed, and that was way past normal deadlines, and so all of a sudden it went from what's available, and so I got into this RU program. I just applied randomly, and it was it was a crazy unique.
And it was at the same university, or
no, it was somewhere else. So St. Cloud State as a PUI doesn't have much research.
I
It
see.
has some research, but not like an R1 master's or PhD grad.
I see.
And so I got into this RU program that was crazy, and it was actually solid state chemistry.
Oh wow!
Yeah, what a coincidence! Right? But it was like, but it was really unique because it wasn't centered at one university. It was actually many professors from different universities. And so what they did is they actually flew us to Clemson University. We did classes on solid state chemistry for a week. Flew out to our respective institutions, and for me that was University of Notre Dame. And I spent the summer working there, and then we flew back at the end and gave talks and presented posters.
Oh, okay.
Which is that's a weird RU.
Yeah.
That was my first experience with research.
Very nice.
It was actually my first time getting on an airplane.
Oh wow! Really? Oh wow!
I grew up like white trash poor, and all this.
Oh my god!
Chemistry can take me places, and that was it. That changed everything.
I see. Wow, that's a very interesting story. Yeah.
Yeah, that's what I said. Like, a lot of us have very convoluted journeys. It's
very convoluted journeys, absolutely. And
speaking of which, going back to your origin story, when did you know you were leaning towards theory? Like, what age did?
When I broke my first test tube.
It was a deterrent.
Well, the teacher basically yelled at me, and that happened to me in high school. It happened to me in college. The first time I picked up a test tube, I just burned through it, and I knew that I just cannot do this. But I actually love experiment. I love talking to experimentalists. Let's just say that, because experiment drives theory. As I said, even Dirac was not thinking really in a vacuum. It's really, you got to think about what's going on in experiment, what are the puzzles out there in the natural universe that are like, and that's what keeps you interested and up, right? Because otherwise it's just like doing some math. So I think, for me, I've always stayed true and close to experiment. I have many experimental friends, but I will break a test tube if I go in there. I just know that.
Yeah. That's fair. Cuddle Puppy following up. So you went from being one of the bullies in 80s movies to being one of the nerds in 80s movies. There was no one good in 80s movies. Go back and watch Revenge of the Nerds. They don't come out good in that one. But no, I was always a little bit of a nerd. Like, I was hardcore into sports, but I'm also like clearly mildly autistic and on the spectrum. So
interesting.
I mean, I don't.
And at that time, it was very difficult to diagnose. So how did you?
Yeah, no, I was never formally diagnosed.
You're not formally
one of those, like, in retrospect, I struggle to, like, make eye contact or social cues and stuff like that. It's like self-diagnosed, but
I see.
But then it was like, I was smart, and so sports came easy. One, my dad was a coach, but two, like, I was smart enough to know where to be, but I wasn't necessarily athletic enough to do what I needed to do.
I see.
Which is why I got hurt.
Well,
So
but you're doing amazingly well. You are now talking to hundreds of people on Twitch, right?
We'll say dozens of people.
Okay. Integrated over time.
Exactly. The absolute value. After 78 of these streams, we've talked to enough people. No, that's true though. We've had what are we at now? 744 followers. So every time we go live, 744 people hear about it. Assuming their notifications are turned on.
I see. Very interesting. Yeah.
But yeah, it's a fun journey, and I have zero regrets about any of that journey. So actually, I mean, being biomedical, I got to dissect a human cadaver.
Oh God. Oh my God. How was that experience, man?
It's a very detached thing at some point, right? Because when you look at it in like the scientific mathematical lens, like it's biomechanics, right?
Absolutely.
It's joints, it's muscles, it's mechanical motion, it's Newtonian physics. So it's easy to like detach from it being a human. Well, at least it was for me, but maybe that's the autism speaking. I don't know.
But when did you do that? In high school or school or in
that was
college?
undergrad. It was,
Undergrad, okay.
Yeah.
Okay.
So I graduated with like 160 credits or something ridiculous because I was on track scholarship, so I had 5 years no matter what. So
I see.
make the most of it, right?
Yeah, absolutely.
Cuddle puppy. I think having 3 average viewers put you in top 25% of Twitch streamers. That's no joke.
That's no joke, man. That's awesome.
Having like 10 streamers puts you in the top 5% or something. Most of Twitch is
awesome.
like people screaming into the vacuum. So Cuddle puppy, as long as you show up, we're good.
That's awesome, man. Yeah. Awesome.
Have you heard Nerdwino's life story? Went from finance bro to in Japan to JPL. I did not know that. I'm familiar with Nerdwino, but I didn't know that's a story. That's crazy.
Wow.
Just fall in love with something and it's easy to commit.
Absolutely. Yeah, that's very important. Falling in love with it, and then you also have to have the guarantee that you can make you can do something productive with it.
Yeah.
Or you hope maybe when I was very young, I wanted to be play cricket, which is a game that's played a lot in in India. But body structure has to support that, right? You got to be good at it. So you got to find what you're good at as well.
Well, not just good at it, to be a top level performer in any sport,
Absolutely.
genetics is writing the check.
Absolutely,
right?
absolutely.
I saw a really interesting analysis of this, of sports like average heights, like a shorter person, it favors gymnastics because of rotational momentum and velocity, and
I see.
You can get more spins in the air, right? The shorter you are, the smaller your R, basically.
Right. Yes.
But the one that they brought up that was very, very specific height dependent, very narrow height distribution is hurdles. So if you do the 110 meter hurdles, there's a certain number of steps between hurdles and a certain height to the hurdle. And so your steps need to be a certain distance to match that, get 4 steps in between each hurdle. So the distribution average height of hurdlers is very specific, which is kind of interesting, at least world-class ones.
I see. And what about Usain Bolt? He breaks everything. Well, he doesn't do hurdles, but
yeah. So
I think if he devoted himself to it, he could do it.
That's what's interesting, because they showed the graph of average sprinter heights for top sprinters in the world, and it's a relatively wide distribution. You can be short and fast or tall and fast.
Right.
But if you're going to hurdle,
you got to have a very specific. I see. Very interesting.
It was a really cool analysis.
That's pretty cool. Yeah.
But if you're going to be a high jumper, you got to be tall. Cricket is wild when the short form is 3-day games.
Well, they're having a what we call a 2020, which is the shortest version of the game, which still takes 3 hours, and that's going to be actually held in the United States. In fact, in Florida, they're going to have games, and the US actually has a cricket team. It's true that it's made up out of a lot of people of Indian origin. And
Indian Americans.
But there's actually a person from New Zealand as well. In fact, there are people who left their home countries to join the US cricket team. To be completely, because you need to stay in the US for 3 years, get a green card and whatnot. And and then you can play for the US cricket team. So you never know, right? You might be watching cricket more than you.
Well, soccer has picked up in popularity. Football, as the rest of the world describes it.
Absolutely. And I think the US soccer team is very good. At least in the World Cup, they give good teams a fight, right? I mean, they were competitive against England, the UK, and so it's I think and they got Messi, right, recently to the Miami, some team in Miami. So I think that it's definitely very popular in the US. It's growing.
Misadventures, cricket, Revenge of the Colonies. The colonies are doing well. I've never heard that before. That's amazing.
So cricket is called an Indian game that was accidentally invented by the British.
That's amazing. Thank you, Misadventures.
Yes.
That's my new fact. Invented by the British. I like it. All right, we should do another prediction because it's been we're about an hour and 10 minutes in.
Yeah, absolutely. Yeah, sure.
Time flies when you're.
Time flies.
How's Mario going?
I'm doing okay. Well, I'm having fun, but it's taking too many lives.
I mean, you have infinite. Infinite minus one. It's still infinite. we do math here on the screen, ladies and gentlemen. All right.
Yeah.
Oh yeah, is this a warp? I haven't.
Oh.
So when I play Mario, I usually skip a lot of the game. There's a bunch of warps that you can take.
I see. Oh.
Have you been using Fire Mario at all? Press the B button.
Oh, B. Okay. I should.
Yeah.
Oh, yeah. The B. Yeah. Awesome.
Cuddle Puppies follow up. Oh, Reese's Pieces. Welcome back to the stream, Reese's Pieces. Thank you for joining us. England is king at inventing games that other countries are better at. Cuddle Puppy. The English conquered the world for spices and then used none of them in their food. Or just
I learned
here.
I learned that chicken tikka masala, which I always thought was an Indian cuisine, it was actually invented by the British. They loved the Indian spices so much that so it's their number one favorite food apparently. Yep.
Follow-up question. Your favorite Indian restaurant in Tallahassee?
Oh, my favorite Indian restaurant. I like Persis. It's close to my home. And they did struggle in between, like the food quality dipped a little bit, but I would say it's a close tie between Persis and Mayuri, and I would say Persis wins out a little bit. Persis is it's on Mahan, very close to Buck Lake. If you go towards Costco and Walmart, it's pretty much on the way.
Okay.
So, yeah.
Any strong opinions about like Taste of India or any of the other?
I liked Essence of India. Taste of India, I don't think I've ever been there. Essence is nice. And Essence is it's on Appalachia Parkway. And so it's always between Persis and Mayuri. And then there's also a place called Aru's, so that's also nice. But yeah,
that's fair. All right, we should do another prediction. Which one do you want to do? What are you in the mood for?
We can do. Let's do quantum computing. Let's talk about quantum mechanics.
The qubits question?
Yeah, sure.
Yeah, let's do it. All right, ladies and gentlemen, be ready to hit that predict button. We are gonna pop up a question right now.
Yeah.
I'll be curious the response on this one. I kind of invented this question.
That's fine.
All right, so we're doing a question. Click the predict button. Well, click the follow button first so you can use your 300 standard internet units and gamble them on this question. But the question is, the number of laptop bits, this is just a standard laptop that you might have now, versus IBM Osprey qubits. And so that's the IBM quantum computer that does exist.
And which you can use.
You can get access to, right?
Absolutely.
It's like grant-based.
Yes.
But yeah, the question is number of bits on a standard laptop versus the IBM Osprey bits, qubits that are available. And I'll give you a hint. There's obviously more bits in a laptop than there are qubits in the current IBM computer. But the question is how much more? Is it more than 1 billion times more? Or is it less than 1 billion times more? Is it 1,000 times more? Is it 10,000? Or is it 10 billion? So throw your predictions in there now. You cannot. Which one is bigger in terms of size? The qubit computer is, right?
Which one is bigger in terms of what size? Like the physical space. Absolutely.
Cooling units and
absolutely. Absolutely.
But which one has
your laptop fits on your lap?
I should have asked that question first. Which one is physically bigger?
Well, this is there are cuddle puppies asking, is this a condensed matter physics themed question?
Yes.
I would say yes, because everything that we're learning in condensed matter is something that we're using towards realizing quantum computers. So, so yes, I would say it is a condensed matter physics themed question. Yes.
All right, so you guys have about 15 seconds left. Do your prediction. Number of bits. How many times more are there bits in a laptop versus qubits in the IBM Osprey quantum computer? Is it greater than 1 billion or less than 1 billion? I don't write out the number 1 billion a lot. All right, Hitesh, what is the answer?
Well, it's more than 1 billion. It's more than 1 billion. So think about your laptop. you have gigabytes of information. Giga is 10 to the 9, it's a billion. And if you have 500 gigabytes, that's 500 times 8, 500 giga, so 500 billion times 8 bits. That's a lot of bits. And so, and in fact, one byte is 8 bits, so that's another factor of 8. Oops.
And the other side of this is IBM's Osprey has 433 qubits.
So it's very far from, it's not even close. Yeah.
Wow.
But that said, a quantum computer is good at certain tasks which a classical computer is not good at, right? So a lot of these things that we were talking about, Ken and I, we're talking about chemistry, quantum chemistry, condensed matter physics. They're based off the laws of quantum mechanics. And in a quantum computer, I need to figure out how to do this, but in a quantum computer...
So if you hold B and run fast and then hold A, you're going to get a higher jump.
Okay.
The longer you hold A.
Right. So in a quantum computer, the things are that bits in your classical computers are just ones and zeros, but in a quantum computer you can have a bit that's half on and half off, 30% off, 70% on. You can have things like that. In fact, a bit can be at any angle, if you like, on what we call a Bloch sphere. So that gives it certain advantages. There are certain kinds of problems that become easier to solve on a quantum computer. But yes, in terms of the number of bits, just in terms of the number of bits, we were very far.
So 433, is that the record qubits for
to
computer?
The best of my knowledge, there are plans to push this to about 1,000, but to the best of my knowledge, this is one of the largest that I know of.
So I'm not familiar. They're using nitrogen vacancies? Is that the...
No, this is based off something called superconducting qubit technology. So it's a squid-based technology, superconducting qubits, which is basically using Josephson junctions. Josephson, actually, there's a very interesting story about Josephson, which is that he was an undergraduate student, taking a condensed matter class, and he challenged the prevailing theory of superconductivity at the time, which basically was from another pioneer called John Bardeen. And a lot of people didn't take Josephson very seriously, but the person who was his instructor turns out to be a very famous physicist himself, P.W. Anderson. And so it turns out that Josephson turned out to be right. Bardeen got a Nobel Prize, and then Josephson got a Nobel Prize the year after. So as an undergraduate student, he basically had the courage to doubt the existing theories. And Josephson junctions now are used very routinely in all sorts of low temperature electronics, ones that rely on superconducting technology. So just have the confidence, guys. If you are challenging your professors, maybe you're onto something.
As long as you have grounds.
Yeah. I'm not able to figure this one out. Okay.
A little bit of speed on the run.
The speed on the B and then A.
Yeah. So hold B and then like push down A while you're. There you go.
I gotta get this thrust. Yeah.
Yep. You get much more height out of the jumps.
Okay. We'll figure it out. I like that you talked about 1 nanometer transistors.
Yeah, misadventures. I like that you talked about 1 nanometer transistors. If we make them smaller, won't they be sort of quantum?
Oh, absolutely. And that's where how to figure that. And that's where we are having these issues with Moore's law that we cannot scale down the size of transistors anymore because we're kind of hitting the quantum limit. And that's basically the limitation of classical computing that we're reaching that very, very soon. But yes, quantum effects are important at those scales. Nanometers is just tens of angstroms, Distance between two hydrogen atoms is of that order, so of the order of a few angstroms. So absolutely, we got to worry about quantum effects at that scale, and that is affecting all sorts of efficiencies and so on for our transistors. And that's why there's so much push on quantum computing. It's like, okay, what next? We've really done very, very well with classical computing. So where are we headed next? Yeah.
Cuddle puppy. So laptops won't become so small that you can hold them with the tweezers. If technology trends are anything, our cell phones are going to be bigger than our computers at some point. They are giant. Oh, see, there you go.
Oh, I got the speed, but I got the turtle. Yeah.
Yeah,
Well, if it becomes that small, how am I going to read it? I'm going to read anything on it.
the other way to frame Moore's law is not just the transistor getting smaller, but the number of transistors you can have per surface area, right? So if your chip size is limited, if your cell phone is such geometric restriction, how many transistors can you get in there? That's the other one, which is really fun.
Right.
We're not talking about but yeah, when you're talking 1 nanometer, you're talking like single molecules. Like you're talking benzene is 0.1 nanometers in size. So yeah, if you want to do anything with like a transition metal complex, you're already looking at, 0.3 nanometers. So single molecules are hard to control. Misadventures. Is there any hope for room temperature superconductors?
Oh,
what is theory analyst?
She touched upon one of our. Do you want to do that now, or maybe wait a little bit?
I think Misadventures already debunked that.
Misadventures, but it's fine. Misadventures is interested, so we'll talk about it a little bit.
Yeah, especially since we're near the mag lab.
Yes. So room temperature superconductivity. That's great. That's a great question, and I brought it up. Absolutely, there are a lot of hoaxes. We brought it up earlier that there was this whole revolution in the 80s where people could find liquid nitrogen superconductors, which are still very cold. It's around 77 Kelvin, 90 Kelvin. But you might say, oh, it's 77 and 90 and room temperature is 300. Right, so it's just a factor of 3. Maybe I forgot a factor somewhere. It's not that bad, but it's been 30 years and we haven't been able to hit that barrier of 300 Kelvin. I would say we have 200 Kelvin superconductors in this family of high temperature superconductors. We haven't hit the room temperature barrier yet. Now that said, you can say, oh, maybe I have more tools at my disposal. Maybe I can subject these materials to high pressure. And that's what people at the Mag Lab have been doing, scientists at the Mag Lab have been doing, and also elsewhere in the world, where they're subjecting materials to very, 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 very high pressures, so 170 GPa, so it's much, 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 much more than 1 atmospheric pressure. And they are able to raise the temperature, the superconducting temperature, to about 250 Kelvin, which I'll just convert it to units that we all can understand. It's like minus 10 Fahrenheit. So that's a unit I cannot understand because I work with Celsius and Kelvin and but if you're in Alaska, that would work.
Sometimes
on some nights, but under a lot of pressure. a lot of pressure. What are
we talking? 10,000?
Yeah, GPa to my factors of 10. Yeah, but something of that order. Yeah, very, very high pressure.
Yeah, that pressure is really hard to maintain. Like mechanical forces alone. Yeah,
absolutely.
Keeping it cool is the least of your worries on that particular.
That's right. So people, absolutely, and scientists have been trying to realize high temperature superconductivity even in hydrogen. You say, hydrogen, I understood that in high school. Well, when you go to very, very high pressure, there's predictions that it should superconduct, but the pressure is tremendously high. And I do agree, minus 10 Fahrenheit is not so bad. But it's just that the pressure is killing you, right? Yeah. Okay, I'm going to try some.
No worries. And also, if you're sick of Mario, we can switch over games.
We can go to maybe the Sega one. Yeah.
You want to do some Sonic?
Sonic, yes.
All right, let's transition to some Sonic the Hedgehog.
I'm not sick of Mario. I'm just.
You want to play Sonic 1 or Sonic 2?
The Sonic 1 is good.
Sonic 2 has tails. If you're all right.
The one that I was playing earlier, Sonic 1.
Yep. Sonic 1 will get you infinite lives.
Okay.
Sega.
Yeah, Sega.
Classic. Minus 10 ain't so bad.
Minus 10 ain't so bad. I agree with that. Minus 10 Fahrenheit is not so bad. It's just, that said, there have been also some erroneous claims. I don't want to use the word fraudulent. I got to start. Yeah.
Start again.
Right. Yep. And this is one, it's very interesting to see the sociology of science. It's something that I didn't think of when I was deciding to get into science, that science is actually a very, very social activity, human activity. How do people respond to all sorts of claims and counterclaims, and what's the
Proposals
dynamics?
and papers.
Proposals and papers. It's a very, very, it's interesting. It's definitely more social an activity than I ever imagined. For sure. Yeah.
Well, we want to believe it was like this intellectual bastion of purity, right? But
Absolutely.
It's just like, hey, if you present well, you're going to get more invites to conferences. You're going to get more funding.
Yes, absolutely.
Like it's crazy.
Right. And communication is an important part of what we do, right? I mean, this activity itself is we're communicating with our audience. I think communicating science is almost on par of doing, at par with doing good science. I mean, if I do some Nobel Prize winning work, but I did it's some forest, that you never heard of.
Yeah.
Well, then you're not going to be interested, right? So I think that aspect is important. It's more important than one would like to think that it is. Yeah.
Yeah, that was something I had to come to terms with. Like, we're all in love with our own research, but the reality is most of what we do will not be particularly useful. We want it to be, but
that's absolutely
if
right.
it's not useful, then what do we do? Well, the answer is the students we train, grad students, the undergrads we teach in class, as well as our science outreach to the public. Arguably, we'll have a bigger impact on those.
Absolutely.
Unless we have something big. We find a positive.
Absolutely. I heard one of the professors in chemistry found a drug for curing cancer.
Bob Holden. It was an anti-breast and ovarian cancer drug.
Awesome. Yeah.
Well, actually, he didn't find the drug. He made the synthesis to make it easier.
Oh,
so
wow.
you could basically, they found this natural product in the Pacific yew tree.
Yeah.
And so you could harvest it from a lot of plants, but you would need to, basically devastate the entire environment to do it.
I see.
But he came up with a synthetic way to do it. And
Oh, wow.
It was very, very valuable.
I see. Oh, very nice. And that made a lot of money for the chemistry department. Is what I
580 million.
Oh God! Wow.
For the patent, not just chemistry, but the patent in general. But
I see. Wow, that's amazing.
So yeah, chemistry got a non-trivial portion that ended up building the chemistry building. So
okay.
If you've been in there, that's the house that Taxol built.
I see. Wow. Yeah. The CSL building, right?
Yep.
Wow. Awesome. Mm-hmm. That's nice. And so that's the thing with research, right? You never know what's going to lead to the next big thing.
Yep.
What's going to be, these crazy positrons, they're going to be used in PET scans. Well, yeah, people will be laughing in the 1930s, but we're not laughing anymore, right?
Exactly.
Yeah. So that's one of those things that I like to believe my work will have this impact, but you never know. Yeah.
Yeah, that's one of the things philosophically, like I don't want to work on something that's popular. It's like
absolutely
perovskite solar cells took over, but I just couldn't get excited because it was already saturated, right? Like working something you hope's going to make a difference, but maybe it doesn't, but you learn something.
That's right. That's right. I agree.
You hope for that patent worth 580 million. We tried. So Sonic, so you had a Nintendo growing up?
At some point, yes, but very briefly, and I did play a little bit of Sonic. Absolutely.
Yeah, so you transitioned to the Sega?
Sega, exactly, yes. And was a Street Fighter in the Nintendo, or I think it was in the
Street
Nintendo.
Fighter was both. It was Super Nintendo and Sega.
Sega, okay.
So you probably played the Sega version?
I played the Sega version, I think, yes, absolutely. And in fact, I had a cousin who was much more into video games than I, so sometimes I just went over to his place and played, but yeah.
Stayed up way too late playing video games. And we all know, just one more game. All right, ladies and gentlemen, just joining us, we're about an hour and a half into the stream. Our guest today is Dr. Hitesh Changlani. He's an expert in condensed matter physics, theoretical condensed matter physics, but also works with experimentalists all the time. He's very interested in how many electrons behave together and what unique manifestations occur. Things like entanglement, things like superconducting. It's all the result of how electrons interact with each other, and describing those systems accurately turns out to be really hard with classical things like Newtonian physics or even density functional theory.
Absolutely.
And so, yeah, that's the world that Hitesh lives in on a daily basis.
So what drives you, Ken? What drives you in the morning?
What drives me, man?
Yeah, going to your lab, and what do you look forward to in the morning?
I haven't done anything in lab in like 7 or 8 years. years. So
Oh, really?
I don't actually do wet chemistry anymore. I spend most of my time at my desk writing papers, writing proposals.
I see.
So yeah.
But you're training students or postdocs.
I train them in mostly the experimental design aspect of it. But
I see.
Like the measurements and stuff, we have like
I see.
facility staff and things like that.
I see.
Like we do ultra fast transient absorption measurements, but I've
nice.
never done it myself. I've never actually done the measurement. So.
And that is another actually important aspect which I was going to touch upon is like what happened in the 1900s and 1930s is like theoretical physics was, you could be in an ivory tower and do theoretical physics, but now it's become a very collaborative game, very collaborative exercise, a very social exercise. And I think that's sort of mimicking how experiment is, right? I mean, you cannot be that lone experimentalist sitting up at night and doing something.
Nope.
You know, that's just not. We all are learning from each other. We are all using things that we probably are not experts at, but you know, we have to combine forces to do nice things. So this is, I think, an important point that you touched upon. That,
Yeah. No, it's really important. And one of the ways I've heard this framed is a lot of the low-hanging fruit has been picked. You can't discover stuff in your garage anymore. That just doesn't happen. You have to have a lot of, complex tools. You need multiple ways to look at something. Like buying a femtosecond laser is $250,000. You're just not a hobbyist doing that kind of measurement.
Right. So that brings me to a point. What do you think is the future of science for a person who doesn't have that privilege, who doesn't have, how are they going to be relevant in this? They might be still curious, they just don't have the opportunities. So what do you think of?
Like a hobbyist scientist?
Yeah, like a hobbyist scientist. Do they have a role to play in future of science?
I think in fostering the next generation of scientists, like the kids that are taking stuff apart and trying to figure out how it works, I think that's foundational.
I see.
But like in terms of actual unique discoveries from a hobbyist scientist, I mean, that's so hard.
That's just very difficult. Absolutely.
Like you have some unique scenarios in maybe mathematics and theory where somebody can do that.
Right.
Who's the Indian guy?
Like you had
Ramanujan.
Ramanujan. Like he had to write to a lot of English professors before one of them took him seriously.
Yeah, exactly.
Yeah, and that's the thing. In theory, this is actually still feasible. When experiment, you got to be connected to some sort of group that has invested many years doing certain kind of technique and so.
You can't do it alone. But I mean, you can spark that curiosity. You can have some fun with it.
Yeah.
Maybe you'll come up with something that's patentable. Oh, nice. Was that first try?
The first try, but I have infinite lives.
Man, who was playing? Was anyone on the stream? The last guest we had play Sonic just struggled at this boss for like 20 lives, and Hitesh just comes in and crushes it.
What is this villain called? What is this guy called?
Robotnik. Have you seen the movies?
No, I haven't.
They're pretty good, actually.
Okay.
They pay homage to the video games. Reese's Pieces. I think there was a recent math hobbyist who discovered new tiling patterns.
I did hear of that. There's a tiling problem, which is like how many kinds of tiles do you need to tile all of space? And I don't know the name of the person. If Reese's Pieces wants to talk about that, they can tell us the name. But it was very, very intriguing and very surprising. It took a lot of people by surprise. And that's where I think computers had some role to play as well. It was like a lot of trial and error that went on into that, I guess. Is that correct, Reese Pieces? Maybe you can tell me more.
Speaking of that, though, I mean, we talked about, the hobbyist scientist is, losing things they can do in their garage. But with things like AI and machine learning, there's a lot of data out there.
Absolutely.
And like discovery doesn't have to happen in a lab. Discovery is just simply patterns and information that already exist. So
absolutely.
Maybe that's where it happens next, right?
Yeah, and that's I think the positive that the condensed matter community is also contributing to. There's a lot of open source codes, including some from our group, that are being used. Like, you're not being charged for it. It's open source. You go to GitHub and you just download it, and you can already start to do research. So I think this is definitely the way forward for hobbyists. Some of them might be on your stream, but I think there's a lot of opportunities to get involved in research, even in your free time. In fact, I had somebody from the finance industry recently contact me, and he had read one of my papers. It was like, oh, look, I did my PhD in this subject, which was high energy physics. But he was always intrigued by, how can he contribute to condensed matter physics. So
Remember this one. You're going to want to get on this side.
I need to get on
the block that way.
Okay.
Sorry, we spent a lot of time. Who was the guest playing Sonic? I didn't know.
Oh, that's very smart.
Cuddle Puppy, thank you for your defense. Are you a moderator, Cuddle Puppy? I can't remember. You're a VIP at least.
Oh, Reese Pieces said, I don't know. But we'll look it up, Reese Pieces. We'll look up that particular news story. Yeah. But thank you for bringing it up. Yeah. Ooh.
Sorry, I forgot what we were just talking about.
No, we were talking about hobbyists, scientists who are hobbyists and then using AI and machine learning and tools that are available online.
Yeah.
So as I said, and as Ken was saying, a lot of these things that we study may appear a little exotic. Why do I care about quantum spin liquid? Or why do I care about a high temperature? Well, high temperature superconductor has direct relevance if we really can find it. But the thing is, along the way, we discover lots of things. We discover lots of ways to simulate electrons in all sorts of environments. And these computational tools are far more general than the world of quantum physics. Yeah. Okay, God, I lost all my coins. Yeah.
Nope, you got one. As long as you have one, you're good.
So in fact, Ken, do you know where the World Wide Web came from? www.
The actual www nomenclature?
Well, I don't know about the nomenclature, but where was it first?
So that was an academic communication chain it was mostly in California, if I'm not mistaken.
Well, to the best of my knowledge, was it Stanford, or was it done at CERN, or was it done in Europe? That's what I thought. It comes from because the particle physics community needed to communicate large amounts of data across satellite channels.
Yeah.
And that www, what we're working on, or we cannot live without it now, right?
Yeah.
Is actually a result of something that came out of the particle physics community.
Nice.
So there's a lot of unexpected outcomes from what we. We were looking for the Higgs boson, but we found something far more useful and practical along the way.
That's very true.
And I think one has to keep that in mind when funding basic research or when supporting basic research, that you might get what you didn't sign up for, and that thing could be fun, it could be destructive, who knows.
True.
Yeah.
Most of the time it's useful.
Most of the time it's useful.
Even if it starts out destructive, it becomes useful.
Well, those who saw Oppenheimer might see a moral dilemma that Oppenheimer had, right? With all these nuclear bombs and atomic bombs.
We can't bring up Oppenheimer because we didn't see the movie. No, it is pretty bad. I think it was Cuddle Puppy. I'm sorry, I haven't seen Oppenheimer yet. A lot of science movies, a lot of sci-fi, but not Oppenheimer. I apologize.
The probability of both of us not seeing it was pretty small.
Yeah, that's true.
It's
that's
pretty
very
small.
True.
Yeah.
But speaking of which, one of the favorite questions we like to ask on stream, and this is we ask every single guest, what movie or TV show gets your discipline right and what gets it wrong? And so this could be loosely defined. It could be theoretical physics, it could be scientists.
Right.
What did you see that made you they did their homework? What did you see that made you cringe?
So I don't know if I'm a minority here, but I thought Big Bang Theory was a little over the top regarding how they portray physicists. I mean, like Sheldon is cool. I mean, I enjoy it. It's not. I'll be honest. Again, Big Bang Theory was nice. I like Sheldon's character, but then everyone thinks that theoretical physicist is really a complete goofball, and that's not true.
Yeah,
we're normal people. We we have our episodes of inspiration and craziness.
Yeah,
but for the most part, we're pretty normal. That didn't annoy me really. I was just like, okay, this is a little bit of an exaggeration. And one of my favorite ones, one of my favorite movies is
following up on Big Bang Theory. Cuddle Puppy. Big Bang Theory was nerd minstrel show. Are you familiar with the minstrel show?
No, I haven't.
Yeah, I've heard that analogy. I've used that as well. That Big Bang Theory was like nerd blackface. like they're pretending to be nerds. They're like the most extreme hyperbolic version of nerds. You're 100% right, Cuddle Puppy. It took it to the extreme. And there's some casual sexism in Big Bang Theory, but we'll not dive into that.
Absolutely. Like Penny's character is, for example, that she's, female and blonde, and there's some there's some stereotyping there. Absolutely.
Well, and there was a great YouTube video I saw on this, and they called it adorkable misogyny, where Sheldon can get away with being condescending to women because it's like, he doesn't understand, he's socially inept. It doesn't address the problematic nature.
I agree with that.
So it's Cuddle Puppy. I completely agree. Sorry to interrupt. All right. So what's the?
So I really loved Beautiful Mind. It was one of my favorite movies for a long time. John Nash's life, really very inspirational. He was a little bit of a jerk early on in life. He was very pretentious and but overall, I would say is very, very inspirational. And how he got over all his medical health issues and still managed to find some inner peace. I think that's very important because as Ken and I were both saying, you do have often some crisis, or at least I can talk for myself, right? You have some midlife crisis sometimes. Where is my work going? What am I doing? And, you have all those sorts of questions in your head. And coming to inner peace with yourself, that's, I think, takes a lot of effort and a lot of, you got to find that equilibrium. And Nash found it in his own way. I mean, his challenges were much, much more difficult than ours.
One of my favorite scenes in that, because it captured so much about what we do, is when he's like chasing pigeons around and like trying to find an equation to describe that.
Absolutely.
We don't do that with pigeons, but that's half the shit we do. We're just literally trying to find a pattern in something that seems like it doesn't have a pattern. And
Absolutely.
Like, that's amazing.
It's amazing. It's amazing. I agree. And it's and I would.
Out of nowhere, the lava. Sniped by lava. That was brutal.
And just think of it, he won a Nobel Prize in economics, right? Being a mathematician, a pure mathematician. So that's where one of these, and I think the scene where they talk about Nash equilibrium and things like that, and he's like completely surprised that, I didn't guess that it would become such a big thing, and it did. So, I mean, that's the kind of day, or that's the kind of impact that you can dream of, that one can dream of as a theorist, particularly.
The broad applicability.
The broad applicability of something, right?
Because it's very specific how we model, but it's just behavior of nature, right? So
absolutely.
That's really fun.
Right.
So a question related to that. So let's say you're in my shoes, you're inviting guests for Ask a Scientist Gaming. You can invite any guest, alive or dead, and you're the host. Who would it be?
Dirac.
Dirac, the go-to.
But the problem is Dirac would not talk because there is a unit of talking which is called Dirac. One Dirac is 1 word per hour.
So he's not known for his.
He's not. So he was
verbosity.
extremely reserved. But whatever he spoke had tremendous impact. His PhD thesis was only 27 pages long. But it's one of the. It was the first thesis on quantum mechanics, and it's loaded with information, right?
That is such a gangster move.
That's a gangster move. Real gangster
27-page thesis.
27-page thesis. And so, I mean, maybe I would want to meet Dirac for sure. But if I wanted a more chatty scientist, maybe it would be Feynman, who was far more social.
He'd be fun.
He was a ladies' man.
Exactly. Follow-up question: what game would Feynman play?
Feynman and I. Okay. You mean one of these video games?
Yeah.
Oh, well, I'll torture him with the Mario.
Everyone should play Mario. He needs to learn.
He needs to play that level on which I was stuck for a good half an hour.
So Dirac's grave is like a mile away from here.
Yes. Oh, from here. Okay.
Have you been to his grave?
I have seen it, but my geography of Dallas is not that great, so I didn't realize it's a mile from here.
Yeah, it's just down the road on Piedmont, actually.
Oh, wow. Okay.
So I've been there a few times, and it was like we'll do bike routes and stuff, and we'll go through the graveyard. But it's one of those, like, I'm not religious, I don't believe in an afterlife, but it's one of those, like, you stop by and it's like, thank you. Like, just like respect.
Really.
This is your monument, but also every textbook ever written.
Absolutely.
Yeah.
Absolutely. Yeah.
But yeah, if you guys are interested, Dirac's grave is actually in Tallahassee. He spent his last, 10 years?
I believe 12 years, something like that. His daughter who lived in Florida, that's what prompted his move from England to here. And I guess he liked the warm weather.
Yeah. And we have Dirac Library, which is right between chemistry and physics, which is kind of fun.
Yes, absolutely.
How often do you go to the library?
Dirac Library, not very often, to be honest. Not very often.
It's crazy, isn't it?
Yeah, it's a little crazy.
Even as a grad student, I remember going fairly regularly.
Yes, absolutely.
But now it's...
But actually, I like places which are not super quiet. I like some white noise. So I like the student union more than I like the libraries.
The new student union?
Yeah, I like the new student union. Yeah. Yes, Dirac would be great to talk to. Ooze goober thing. Spin, yes, absolutely. Yeah, absolutely. Spin half particles. In fact, there's an interesting story about spin, which was actually discovered experimentally, and people didn't know what to call it. You know, there's this extra unit of angular momentum, and they thought, oh, maybe that's coming from the electron spinning on its axis. Whatever that means. Well, it was shown to be not quite the right way to think about it. That would break all sorts of relativistic considerations and so on. And then it turns out that Dirac was prompted to think of a relativistic generalization of the Schrödinger equation. So Schrödinger wrote down his famous wave equation. Some of you may have seen it back in 1926, and Dirac was like, I don't like this because this has two derivatives of x on one side and one derivative of time on the other side. And Einstein is telling me that space and time should be thought of on exactly the same footing. And so I don't like that there's two derivatives on one side and one derivative. Just this quote-unquote simple observation prompted him to think about what would be an equation where you have space and time on an equal footing. And that's basically the Dirac equation. That's the one that predicted these antiparticles the first time. Oops. And so, yeah, I mean, this whole idea of spin is amazing. It just comes out of Dirac equation very naturally. But because we didn't have a very elegant theory, we had to put it by hand in some of the early versions of quantum mechanics. So I think this just really reinforces my belief that if you have the right way of thinking about it, the right variables, the right, just the right language, things become much easier to explain and understand, theoretically at least. Yeah.
I mean, so on that front, you kind of recount that as like it didn't feel right, like it looked discomforting. And so like the analogy in chemistry is someone can draw a molecule on the board and I can say to a certain degree just intuitively like that is unstable or that looks like it's angry or that has uncomfortable bonds. And so do you feel that with equations when you see them?
Absolutely. Well, I can't say that I have that level of intuition like Dirac, of course.
Yeah,
but absolutely, just something doesn't feel right. And this is actually brings us to this topic of neural networks and machine learning as well. Because I mean, you think about it, our human brains are, when I throw a ball to a person, I'm not actually calculating projectile motion. I'm not figuring out. My brain has accustomed itself to thinking about, okay, I know this is roughly right? Yeah. This is the force or this is the velocity with which I need to throw something. So this is pretty amazing because my kid doesn't know anything about Newtonian mechanics, but he can throw a ball. Right. And so this is a kind of intuition that I feel is, maybe it's something specific to humans, maybe not. I don't know, but this always boggles my mind. Like,
I mean, but that's kind of how machine learning works, though, right? Like there's no set equation. It's just like comes up with a polynomial to say the ball should go this far.
Absolutely,
like because you care.
Absolutely. It's because it's not trying to reduce the number of variables necessarily, and it's just trying to look for some correlations, and that's good enough to explain many patterns that we are seeing in nature.
So how do you feel about the machine learning AI revolution as applied to the sciences?
I actually like it a lot in terms of practical things. Like it's created a lot of practical tools. I'm a big fan of ChatGPT, I would say. But when it comes to quantum physics, it's not so clear that it has had the kind of impact that we would have liked to like for it to have. Like, I mean, there are many problems in quantum physics that we are studying as a group for many years, for 10 years, and it hasn't had that kind of impact yet. But I would say it's still early days, right? Machine learning as applied to quantum physics is still in its early days. It's still in its infancy. Think about quantum computers. They were postulated or hypothesized in 1980s, and it took a good 40 years, right? Till we're seeing the first quantum computers, and we're still not completely there. So
33 qubits.
433 qubits. Right. So I'm very optimistic about machine learning AI. At the very least, it's made people realize that you need computing to do theoretical physics these days. You got to realize that you got to use the advantage that computers give to you, which is actually surprisingly not a common sentiment. You know, a lot of people still think, oh, physicists are just sitting with pen and paper in their office. But that's not true anymore. So I'm optimistic.
Yeah.
I'll just say that. Yeah. Obviously, with everything in life, there's some hype, but overall, I'm positively amazed by all the developments in the field. Yes.
Nice. Oh no! You made it through the hard part and got wrecked. Rage. There you go. You get the rage emote.
Oh God.
Oh man. All right. So we're wow. It's 9:50 already. What else?
So I thought there was a question. Sounds like Dirac wasn't much of an explainer. Look, there was a lot to explain. And he was trying to come up with the law of nature. He was trying to come up with the law of nature. So when you're trying to do that level of theory where you don't have anything else to refer to except that you say, oh, I got to get the Schrodinger equation as some limit of my equation. You got to have a lot of intuition. You got to have a lot of inspiration from symmetries and from mathematical intuition, mathematical principles. So for him, beauty in mathematics was the driving force. And if you ask, oh, could he explain his motivation for doing something? Yeah, I think it would be difficult to get that out of Dirac, because as I said, the unit of one Dirac is 1 word per hour. So yeah, you would have a very difficult time figuring out from Dirac how he arrived at that equation. But yeah.
Who was it? Somebody added the word misadventure, heuristics. I don't know if you heard of that. This how you go about addressing a problem or how you think about a problem.
Yeah.
That's heuristics.
Absolutely. Yes.
And some of it's intuition, some of it's formalized.
Yes.
Some things feel right, some things feel wrong, and we can't necessarily formalize why.
Absolutely. And that's actually something, and that's a great question. And I think that's a style of doing things that is very important to be a good researcher. Because there are some students who are like, oh, I'll read this entire book and then I'll solve this particular problem. Well, it's not going to happen that way. You got to learn on the fly. You got to develop your intuition on the fly. Everything happens because there's a problem that is being, that is awaiting an explanation from a smart person like yourself. I think this developing this heuristics, it's slightly underrated, because a lot of people think, oh, you got to be a smart theorist to do theory. Well, you just got to ask the right questions. That's equally important way of doing science.
And you have to be willing to be a computer programmer.
And you got to, if you want to be part of my group.
It's most groups, right? I mean,
most groups they require some. Yeah,
you can't do it without programming to some degree.
Absolutely.
So do you try to steal students from like computer science, scientific computing, mathematics?
I haven't tried that. I haven't tried that yet. We generally accept students into the physics program, and then they approach me, and when they're applying, it's mostly physics students who apply. That has not happened that I've had a student from computer science who wanted to do quantum physics. That hasn't happened yet. But I just got tenure, right? So it might happen. It might happen in the future. I don't know. Yeah.
Yeah. Well, our guest in 2 weeks is Sachin.
Oh, yeah, Sachin Shanbhai. Okay.
Yeah. So he's a scientific computing world.
Yes. Okay. I see. Nice.
JTP, my undergraduate research was focused on using machine learning to predict coupled clustered wave functions.
Oh, wow.
Clustered wave functions.
Awesome.
Machine learning for quantum mechanics is in its infancy, but I believe it shows great promise.
Absolutely. So
Method development, right?
I agree a lot, and thank you for that question. I never knew somebody who would do couple cluster would join this video game stream. So I'm really glad that
One of us.
one of us. I'm glad that you're here. So couple cluster has been immensely successful in all sorts of problems in chemistry, in particular. In fact, Eugene Deprince in your department, the chemistry department, does some of that as well.
Been our guest several times in the stream.
Oh wow, really?
Eugene was my first guest.
Oh, I see.
Yeah.
Oh wow.
So Eugene's my closest friend in the department, actually.
I see. And so the thing about couple clusters, you need a good starting point. Oh, I'm Eugene's student. Okay,
Oh, I know
makes
who
a
that
lot of
is.
sense.
Yeah.
Is that Justin?
Are you on his committee?
Well, we're collaborating on something. Yeah.
Oh, you are? That's fun. Oh, we
Justin,
gave it away.
Justin. Hey, Justin.
Doxed by the internet.
Hey, Justin. Yeah, we should discuss our project.
Over Twitch.
Over
While
Sonic
gaming and
and
drinking.
you can
Only
see-
good things can happen.
Right. So Justin is doing some nice things with couple cluster.
Yeah.
And a couple cluster is very good when you know a good starting point, when you know a good reference function, and then you can build correlations on top of it. As I told you, density function theory is a mean field theory, but couple cluster is a correlated theory that builds on top of a mean field theory. So I know it sounds all complicated, but I'm talking to Justin at this point. So yes, Justin, couple cluster is very good when you know the starting point. The issue with couple cluster, if I may call it an issue, is that you don't know often what the starting point is. And and so that's where I think there's a lot of room for improvement and algorithm development in that direction, for sure. Yeah, like how do we choose the good starting point to build on top of?
All right, Lori, sorry I'm late. What's the drink of choice tonight? Oh, we're being casual tonight.
yeah.
I guess sometimes they don't care, so I default to Blue Moon, as Lori knows.
Yeah.
So Lori's our graduate advisor, actually.
Okay,
So
hi.
she's- Yeah.
Hi, hello.
Lori, here's cheers to another cycle of graduate admissions being done.
How do I get out of this fire?
I think jump to the right. There's probably a platform you can
okay,
get
I
up
see.
on.
Oh yeah, you're right. Oh, you played this many more times. Then
I've seen the struggles.
okay, great. Hi, Laurie, and hi, Justin. Hi, everyone. Yeah.
But yeah, Lori, I'm exhausted, but I'm glad the hardest is behind us. So how is admissions for you guys with the countries of concern? Chinese,
Well,
Russian,
that's I think that's you touched a nerve there, Ken. It's a little tricky. The directive was somewhat vague when I last heard.
Yeah.
But the general sentiment is that we're not going to be able to really overrule this in some sense. We got to make the best of what we have. And so we are finding actually a lot of countries which were maybe not considered earlier are actually producing very good students. We have somebody from Jordan, I have somebody from Vietnam.
Wow.
And they are the top students in my quantum mechanics class. So I'm just trying to look at the positives in an otherwise bleak scenario.
Yeah. Have you seen your recruiting numbers? Has it affected incoming class or anything like that?
Not yet, not to the best of my knowledge. It
Okay.
hasn't affected the numbers, but we'll see the entire impact of that. Maybe when they actually come in, right? I mean, depending on the number of acceptances and so on. So,
Yeah, that's what we're wrestling with right now. Is just like, how do you balance that?
Right.
For those of you not familiar, the state of Florida has implemented a rule that if you want to hire someone from, they call it countries of concern, and so on this list is China, Russia, North Korea, Venezuela. I don't remember what else is there, but
Yeah, Syria, I think also.
Syria, yeah, there's 6 countries. You have to get special approval, but that approval doesn't come in time to admit them to our graduate classes. So
Right.
we are limited on, we can't basically accept students from China or Russia.
Right.
Interestingly, a loophole on this is if they self-pay for the first year. Iran is the other one. Yeah, I should. probably
Okay,
pick
right,
that
right,
one.
right. Yes.
But yeah, they can self-pay.
I
And
see.
if they do that for 2 semesters, then they have a domestic address, and then they can be hired.
I see.
So
I see. Oh, okay.
that's something we can add to our letters.
Yeah, unfortunately, there were many students from China who contacted me, and these students are very bright, but I just couldn't promise anything. I was like, I don't know what's going to happen. So, yeah.
No, it's been a mess.
It's been a mess, and let the politicians do what they want to, but let's let science just happen. Huh?
Yeah, let us do what we want.
Let us do what we want to as well.
Yeah. No, but we survived. Lori, thank you for all your help.
Say that again. Sorry.
I was just saying, Lori, thank you for all your help. We
Thank you,
survived
Lori,
another
yes.
cycle because it's a battle.
It's a battle, yeah. For sure.
Expensive loophole, yes. Self-paid for a couple semesters. What is that? Tuition? I don't know what that is.
When
That's
you
gotta
convert
be-
things from Asian currencies to US dollars, it's probably a lot.
Yeah, plus no salary. So 15 grand for classes plus whatever.
Yeah.
Oof.
Yeah.
Expensive loophole is right.
Expensive loophole, yeah.
Sorry to touch on $1,100 per credit. At
Oh,
FSU,
God. Oh,
which is still relatively cheap depending
compared to other
most
places.
schools. Yeah.
To many other places.
Yeah.
So Laurie has been in the chemistry department
Yes.
for how long?
Oh,
if I may
man.
ask. If I may ask.
She had a brief hiatus, but without that, what, 8 years, Lori? Something like that?
Oh wow. Okay.
7 or 8 years? Yeah, she's our go-to on recruiting and admissions and
I see.
orientation and everything.
And does she play a lot of video games?
Did she watch the stream every
She
time?
watches.
Lori's one of our regulars.
What game does she like?
She has learned so much about video gaming and oh man,
Oh man, that was fireball. I see, well.
All right, ladies and gentlemen, we're 2 hours in. It is 10 o'clock. We'll start NARC probably in about 30 minutes or so for those of you that are exclusively tuning in to watch Hitesh play NARC.
Oh, God.
But if you're here for the science, you guys want to know about theoretical condensed matter physics, he is happy to answer questions regarding many electron systems, how you model them, how they manifest in things like magnetism. Speaking of which, we should do a prediction. What do you want to do?
Sure. We can do which is larger.
Okay.
Maybe. Yeah. I like large and small. Yeah. People in my class are like, is this small? Is this large? I'm like, relative to what?
Yeah, exactly.
Is 5 a big number? Relative to what? Right? Compared to 0.001. Yeah, 5 is infinite for me. So,
I harp on, like, when I'm reviewing papers, like when people say something is fast, I'm like, fast. Femtosecond fast or Usain Bolt fast. Like, those are very different scales.
So it turns out that there was a Nobel Prize given in physics just last year for what is called attosecond physics, which is 10 to the minus 18 seconds.
Fast.
That's fast. That's fast because 1 second is like the age of the universe for them.
Yeah.
It's for 10 to the minus 18 seconds.
Yeah. And like when you're attoseconds, that's watching electrons move.
Yeah, absolutely.
Like, and there's just, we don't even, what's faster than that? It's crazy.
Yeah.
All right. So those of you not following, click the follow button. We're going to put up a prediction right now. Predictions on our stream are not game related. They could be. We could say, is Hitesh going to beat the lava? The answer is yes this round, maybe. But we do
I'm more
science
enjoying
questions.
the science part. Let's leave it at that.
So we're going to pop up a science question right now. And the question is, which is larger, the number of particles in the known universe or the number of quantum states that you can generate with 300 electrons? And so this goes back to the idea of quantum computing. It's not just one state per electron. There's many states. The question is, which number is bigger? The number of quantum states you can generate with 300 electrons or the total number of particles in the known universe? That is an estimate, obviously, but a fairly accurate estimate. Tesh, is there anything you want to add to that question?
Yeah, I know Justin is going to get it right.
Justin, no pressure. We want exact numbers from
sure.
you. Oh no, they're gonna look at it, then biasing it. We'll see.
Oh God.
Your imaginary internet points. But if you guys aren't following, click the follow button.
Justin should not be allowed on this
You can
one.
probably spin roll through those caterpillars. So you walk towards them and press down.
Right.
Do the spin roll. I like it. Gaming advice.
Oh, nice. Awesome. Thank you.
Puppy.
Yeah. This one.
Justin's gonna say, what? No, have some pride. Do a prediction. Just guess one way or the other.
Do it.
I won't tell Hitesh what you answered.
Justin will play video games together one day. Yeah. Awesome. Justin, do you like video games? I mean, playing video game, not watching. Oh.
It's one of those things. Anyone under the age of about 35 right now is a gamer. Like they either cell phone or computer. Like 90% of them are gamers.
So when I went to college, people were like playing for 10 hours, 12 hours a day. I felt like this is a bit too much. But as long as you are not getting addicted, I'm okay with that. Yeah.
As long as it doesn't disrupt your.
Yeah, it disrupts. I mean, people are like staying up in the middle of the night and like, oh, you got an assignment due. I'm like, no, I gotta play this game.
Volcano Docs, is that a Twitch streamer or that's on TikTok? Volcano Doc.
But now that I've heard that it has some mental health benefits, oh no, there's some studies on.
Volcano Doc on Twitch. Look at that.
She was a high school dropper. Oh, okay.
A Twitch streamer. That's fun. I'm learning new people. Volcano Doc. That's fun. I'm gonna follow. I'm looking for streamers. Especially people we can raid on Wednesday night at 11 o'clock. How many people are actually on? Go. All right, prediction is ended. All right, which is larger, Hitesh?
Yeah, I'm very curious about that.
Universe, quantum states of 300 electrons. What's the?
Do we see the results of the poll? Like how many people got it?
So majority of people said quantum states of 300 electrons.
Oh, awesome!
They bet big on that. We have a
you are right.
bet from Lori.
You are right.
Oh, it's too bad, Lori. You would have got a 16-1 to pay out.
You are absolutely right. Maybe this question is too simple.
Well, it's that's what's hard about these questions.
Yeah.
I didn't talk them through with you earlier, but there's like meta information. Like, why would you ask if the answer wasn't?
I see.
Like, because you're a quantum computing guy, right?
Yes,
so you want to make that one this. Right. So if you did 20 electrons, it would have gone the other way, presumably.
Right. I understand.
Yeah.
It's okay. It's all part of life.
Next time you're on, give the numbers.
20 years down the line, Next eclipse, you sure?
2044. Oh no, I'm having David Collins on. My on too. Yeah. Now
so does anyone know? Well, I don't know if I can ask, but does anyone know how many particles there are in the universe, in the observable universe?
Ooh, good question. Anyone want to throw that number in chat? Justin?
Just no.
Cuddle Puppy says
there are only three particles.
Earth, wind, and fire, right?
Well, it's bigger than that, Justin.
10 to 52?
I think it's bigger than that. Well, that's what Google tells me. It's bigger than that.
What's the?
It's 10 to the 80. So it's 1 followed by 80 zeros.
Jeez.
Yeah. But when you're at 52, 10 to the 52, 10 to the, it's all large for me.
It's many. It's many bodies.
Many particles. 10 to the 80. And that's and you just look at 300 electrons and you can ask, in quantum mechanics you have things are on and off or between on and off. So how many possibilities can you have? It's much more than the number of atoms in our observable universe. It's just so crazy that so we have all that information that we are harnessing on this tiny quantum computer on planet Earth, and the hope is that we can do interesting things with it, interesting calculations, interesting chemistry maybe on it. That's certainly the hope of the future hope. Harnessing these large number of states to calculate. I should put a number with a
exclamation point. You won't know if it's a factorial or an exclamation.
Absolutely.
That is important.
It's that large. Absolutely.
100 or 100 factorial are very different numbers.
Absolutely.
Thank you, Cuddle Puppy.
Absolutely.
That's really fun.
I need to get some rings. But 94% got it. I'm pretty amazed. Yeah. Great. Wonderful.
Yeah, so that 94%, interestingly, Twitch, it does the payout based on the amount that they gamble.
Okay.
And so it's not just the number of people on each side, it's how much they are sort of, which I'm intrigued by. I would love to write a test where students gamble certain amounts of points.
I see.
Like, depending on your degree of confidence, you do higher or lower.
Oh.
But I don't know.
I have the best. I'm embarrassed now. Thank you, Laurie. That's very
King
nice.
Lai.
That's very
Lonnie
very
might have
nice
the
of you.
best laugh of all your guests I've seen. That I hadn't crossed my mind as a metric, but congratulations.
Thank you. That's very nice. And I'm a little embarrassed now.
Yes, you're popular.
I should not laugh. I should cry because Sonic is losing his lives.
Oh no,
Sonic a cat, right? Felix. No, what's his name?
Sonic?
Sonic. What is he?
Hedgehog.
Hedgehog.
Sonic
Sorry.
the Hedgehog.
But there's also Felix, right?
Felix the cat.
Yeah, there's Felix the cat. That's a different
separate,
game.
Yeah, that's
a different game. Sonic is a hedgehog. Yes.
Yeah,
Sonic
Felix
the-
is originally I think a comic book, then a cartoon, and also a video game.
Yeah. I see.
So yeah, speaking of which, so we're I mean 10 o'clock. We have about 22 minutes left. Is there anything else you want to play? Do you want to try? A different Mario, a different Sonic, Street Fighter.
Yeah, I don't mind Street Fighter. I wanna beat Ken.
Okay. So are you okay? I have Super Nintendo.
Yeah,
Street
Super
Fighter.
Nintendo is fine.
All right. Let's,
Yeah, I want to play Street Fighter with Ken, but he refuses to play two-player games with me because he's looking at the Twitch stream. But
all right,
I thought I would. I thought I would.
You want to combat me? I'm sorry, I didn't set up two controllers. I should have.
No, that's
The
okay.
challenge.
This one, right? Super Nintendo. This is okay. And I just to
Yep.
start.
So yeah, start button. You might have to press that one hard. That's a little janky.
No
of a
problem. No
controller.
problem. No problem. It's okay. Yeah. Oh wow. This Ryu Honda. Oh man, this is.
Is this the one?
Yeah. This is the one, man. This
And
is
down,
brought back my
there it is.
childhood. Yeah, Chun Li. Yeah. Oh man.
Ken, Chun-Li.
And this one.
Classic.
That's him. Oh, Ken. I will be Ryu. Okay, I will be Ryu.
But yeah, if you guys have questions for Hitesh, he's happy to answer them. Many electron systems, theoretical physics, magnetism, quantum computing, anything you guys have, throw them in chat. We are happy to answer them while playing a little bit of Street Fighter.
Oh,
This one, what was this timeline? This would have been high school for you?
Probably
Middle
yes.
school,
Yeah, high school.
maybe?
No, high school. I think. Yeah, oh, middle school. That's right. That's more accurate. Yeah.
This was you played with
I'm
friends?
right. Yeah, friends, cousin. Yeah, we all played this and one. I mostly just hit some random buttons.
Look at that. Don't worry. That's how most of us start. Man, have you seen modern fighting games though?
Like which one? Mortal Kombat?
Yeah, like Mortal Kombat
I've seen.
11 or Mortal Kombat
Yeah.
1, I guess is the newest iteration. I don't know, they restarted.
I have seen it. And there's a movie, right? Mortal Kombat is a movie, yeah.
Yeah, there was the 90s movie and then there's a new movie. The original one is so campy amazing.
Oh, wow. Oh my god, this Ken.
All right, what other questions do we have? to ask?
Justin says the scaling of configuration interaction, which is this method, this exact method,
Yeah, see,
gives him nightmares.
it should. Beyond 4 electrons. Good luck. I like it. All right. Other one we like to ask regularly. Unlimited budget, no moral qualms. I realize you're a theoretician, but if there was something to test a theory, or you could invest all the money in making a spin liquid of particular, where would you invest that money?
That's a question I thought about at some point in my life. I have no idea what I would spend. I honestly would benefit a lot from just having more postdocs. That's
That's what you're going for.
because all the experiments I conduct are mostly in my head or on a computer. So the resources I need are mostly human and more manpower to do the calculations that I do. But that said, I mean, there are definitely very intriguing things because we brought up things about space exploration, and I would be very curious about we see these sightings of UFOs and everything. Am I on computer mode or? I would be very intrigued to know if there's life elsewhere in the universe. Like, I don't think that the probability of us being where we are in this blue speckle in the black sky is is a chance. I think there's got to be more to it. So the space exploration is where I would spend a lot of money, probably.
Wow. Yeah.
I mean, of course, there are barriers. We cannot cross those barriers. Light travels at a certain speed. We cannot cross that speed, sure. But even within the realm of what is observable, I would say if I had a lot of money, I would probably spend it on finding new forms of life elsewhere in the universe.
I mean, if we surrounded our solar system with like 1,000 Webb telescopes, right? Like just filled the atmosphere, pointed all directions, and just acquired info,
Right.
the amount of data we would get is profound.
That's right. I think I just got logged out of the game, so I'm going to start.
I think you lost.
I lost so badly then.
Huggy Beer has redeemed request a factoid. So
Okay. Sure, factoid. So what do? I just ask?
yeah, you're just gonna tell them. They just want an information.
Okay.
bomb.
Okay. Well, we were talking a lot about Dirac, and so I'm going to use this opportunity to say something about, well, a lot more people know about Albert Einstein, and fewer people know about Dirac. So I'm just going to say, Einstein said this of Dirac: I have trouble with Dirac. This balancing on the dizzying path between genius and madness is awful. So that was Einstein's opinion of Dirac when Dirac was going to write a letter of when Einstein was writing a letter of recommendation for Dirac. This is what he said.
That was in the letter.
Yeah, well, I don't know if it was written or whether he said it, but this quote is attributed to him. Yeah. So the path between genius and madness.
Man.
Yeah, if I come across a little bit crazy, well, I'm not a genius, but I might be mad.
When Einstein is like, yeah, he's a little socially inept. Amongst the physicists of the world, when you're the weird one.
Which I'm blank.
I'm sure Dirac was somewhere on the not atypical something spectrum.
Absolutely, and I think some people say that he might have been mildly autistic
or extremely.
Absolutely.
Still functional, but.
Absolutely, and Dirac had a very troubled childhood. I mean, his father was very strict. His father was a Frenchman, and or at least a person of French origin, and he wanted Dirac to speak in French, and then Dirac was like, I just prefer to be quiet. So that explains some of his quiet demeanor, actually.
Wow.
And bringing up the thing about mental health, we discussed it earlier. Dirac's brother unfortunately committed suicide when he was very young, so that had also a profound impact on Dirac. Like, he didn't, an event of that magnitude creates a lot of problems. But Dirac's wife, I forgot her name, she was Eugene Wigner's sister. I'm going to maybe just log out of the game. Yeah, Dirac's wife, who was Eugene Wigner's sister, was the more proactive one in the relationship, in the sense that she approached Dirac. She's the one who, made Dirac feel normal again. And then, she was also divorced, I believe. So when they married, then Dirac was like, oh, this is the happiest I've been in a really long time. So
whatever he was, she was into it. It's like that guy. That guy sitting quiet in the corner, potentially mumbling. That's amazing. Well, I'm genuinely curious, like, in the privacy of their own home, was he more engaged with her? Like, was there casual conversation, or I don't know? I
have no idea. I think I got logged out of the game again, unfortunately. So I'm going to just press start. And I'm trying to do that. And
it's not going.
Do you want to try for me?
Maybe.
Is this the correct? Or I can go back to Mario, Sonic, whatever you want.
Yeah, no, you're good.
It's good, right? It's good. Okay, cool.
There she blows.
Huggy Beer. It's been a minute since we had a physicist on. That's true. It has been a while. Do you have any insights into matter popping into a vacuum?
Matter popping into a vacuum. Yeah, so
spontaneous existence.
Well, yeah, I mean, that's a great question. And, we know from Einstein that E is equal to mc square, and energy and mass can basically convert it into one another. And so, in fact, you have high energy photons, gamma rays, that actually give you a positron and an electron, right? That's how they're created, out of nothing, you might say. but then it's also photons, right, which are energy. And then you can have the reverse process where a particle meets its antiparticle. I think I got knocked out again. Particle meets its antiparticle, and then they can basically annihilate to give you energy, right, which is photons. So this kind of conversion between energy and mass happens all the time, and particularly happens at higher energy for sure. Yes, and this can happen. This does happen. Matter popping into the vacuum, but that's when it meets its antimatter, or that's at least our understanding of nature right now. Yes.
Cuddle puppy. Yet every single week we have a chemist on. That's a biased stream. Hey, to be fair, I could also qualify as a material science or
Absolutely.
chemical engineer, or maybe a photophysicist, molecular photophysics, photochemistry.
I need to press start.
Lori, is Ken on this game you, Dr. Hansen? No.
No.
Fun factoid, I do have a black belt in karate.
Oh wow!
So, mildly related.
I go to press start again. Sorry.
Okay, chemist. I've been pigeonholed.
Okay.
Is it going?
No, it's not. It's on computer. It's on auto. It's okay. It's not a big deal. I can just go back to the. I can go back to Sonic or something. Whatever.
Man.
It's not a big deal. I'm probably not doing a good job here. Yeah.
I don't know. The start button on that controller is
No, it's okay. It's not a big deal. It's not a problem. Yeah.
It's hard to find working Super Nintendo controllers.
No problem at all. I'll go back to Mario maybe. How about that?
Mario, original Mario, or you want to try Mario
I can try the new
3?
one. Yeah. Let me upgrade my knowledge of what's going on. Right?
All right.
Yeah.
Not the new one, but
yeah.
we'll do Mario 3.
And this is on the Nintendo, right?
Yep, that one. Yep.
Ooh.
I'm a pitiful green belt in Taekwondo.
Oh, really? And when did you get that one, Ken?
When did I? No, this is Lori's.
Oh, somebody else. Okay. But you have a black belt, you
So I
said.
got a black belt. I was,
Okay.
what would I have been? It was undergrad. I probably would have been 20 years old, something like that.
Oh, wow.
But yeah, I was.
I don't have a black belt. I have a yellow, but they basically were generous. I didn't deserve even a yellow one. I'm pretty bad at that stuff. Okay, so yeah.
There we go.
Oh, and this is different levels, I guess.
Yep.
One. Okay, so I just do start. Yeah. This is what I do. Just start. Yeah.
Mute that. Misadventures might have been running in the background. I don't know what happened there. Interesting.
Okay, I got this. Cuddle puppy when they need sarcasm.
Sarcasms. I think most of us have a healthy dose of sarcasm and cynicism. Otherwise, we couldn't do the job that we do.
the job. Absolutely, we got it. Oh, I missed my mushroom.
Just be skeptical, just a little bit. So, did you play this one at all, Mario 3?
This one I don't remember, but I like it. I like the graphics.
Slightly better graphics. It's like it's real. It's living.
There was a Mario movie as well, right?
Yep. There was the original John Leguizamo and Bob. What is his name? I should know this. Someone in chat is going to figure this out. Bob.
Oh, okay.
What the hell is?
Well, they have access.
Roger Rabbit.
They have access to Wikipedia. We don't.
I do. I should just be
Oh,
Bob Hoskins. Yeah, there we go. Matt isn't a Robert. Welcome back to the stream. Thank you for joining us. Hoskins. There it is. Hoskins from Who Framed Roger Rabbit. So there's that one, and then there's a recent one that's the cartoon, which is pretty fun. It's not like a great. The surrealist masterpiece, absolutely. So, a movie that gets your discipline right, obviously Super Mario Brothers, quantum teleportation, perfect.
What is the movie that you like, Ken? You didn't tell me that.
Oh, in terms of science related to my expertise,
Expertise, yeah.
So one of my favorites is Real Genius. It was from like that would have been what, early 90s. It was it's actually, they're developing a laser. It's not Caltech. I don't remember what the artificial school, but it was filmed at Caltech, and it's all about grad students working. Yes, the Val Kilmer one, Cuddle Puppy, you are exactly correct.
Val Kilmer, okay.
But it's talking about, developing a laser, and they talk about, excited states and coupling to ground states and potential energy surface and lasing excited iodide, and it was like, yes. And not only that, but they got the like the absurdities of the grad school experience. Just, you know, hanging out with friends, talking science, like trying to do research while having a life. Like I strongly recommend Real Genius for anyone that's interested.
Which year was this in?
Oh, which year? It would have been, I think it was early 90s.
90s? Oh, wow. Well, I didn't know what grad school was like.
Oh, no, 1985. I was late on that one.
I had no understanding of what grad school, what does it even mean? My parents were like, my mother is a teacher in a school, and my father works in the diamond business. I had no idea what I was signing up for. You know, I was just like following friends.
Does your dad still work in the diamond industry?
Well, he retired, but yeah. So in India it's a hub for diamonds and gold. You know, there's people invest a lot in this sort of stuff.
Yeah.
So there's a very big market there. Yeah. No, he doesn't work anymore. He's retired effectively. Yeah.
But yeah, just put a link in chat if you guys want to check out Real Genius. If you haven't seen it and you're like a grad student or gone to grad school, I strongly recommend it. It's just a fun. I mean, it's campy like 80s humor, but also it kind of captures life.
What do you think of? You like PhD comics?
You love PhD comics.
It's awesome, right? They made a movie on it as well, which I did not watch, but I like the comics.
I haven't seen the movie, but
even I haven't seen it. Yeah.
He was what is his name?
George Cham, is that right?
Yeah. Were you around when he visited FSU? You probably wouldn't have been. It was before you, actually.
I don't remember him. Yeah.
So he was, I got to meet with him actually, which is pretty fun. So he gave a talk in the main big auditorium, and the grad student association is what organized the visit.
I see.
And I got to meet with him, which is kind of fun.
Yeah, well. And I think there are a couple of questions. Speaking of condensed matter,
this is Mario, am I right?
This is Mario.
When I think of photon engineers, I think of Val Kilmer. Absolutely. That movie is spectacular. Oh man! All right. Is there any other questions?
Do you want
through like 4 on the list?
Okay. Do you want to do?
Oh, we can do another prediction.
Yeah. Let's do one of the predictions. Let's see. We'll do. Well, maybe I revealed too many answers. We'll do graphene. What about graphene?
All right. Graphene. We'll see how common this story is.
Yeah, we'll see.
I don't know, amongst the casual viewership, and by casual I mean
we'll see
how several grad students in here.
Yeah.
All right. All right, so we're going to pop up a prediction right now. If you're not following, click the follow button. Use your standard internet units to gamble on this question, depending on your degree of confidence. Click the predict button, and you're going to make a prediction. Graphene was first made in lab using either chemical vapor deposition or Scotch tape and a pencil. Which one of those methods was first used to make graphene? So that's basically a thin single layer of graphite. How was it made? Chemical vapor deposition or Scotch tape and a pencil? I just heard of another 2D material. Yeah, 2D materials are hot right now.
Absolutely hot.
Very popular. They just made a 2D gold layer. I don't know if you saw that.
I didn't see that.
Atomically thin gold. Yeah, they called it goldine.
Goldine.
That's just ridiculous. Goldine. You take that back, Huggy Beer. Unacceptable. Goldine. Oh, man.
Well, again, it's one of those things like theorists for a long time imagined, can you have something which is two-dimensional, but experiment took time to catch up. Right? I mean, there was always this theoretical curiosity that, and people had calculated what we call an electronic band structure, which is that we were able to do some calculations of how electrons are hopping around on this two-dimensional layer. But there was no experiment. There was nothing, so we'll see how the answers are.
Yeah, no, Huggy Beer, I think you're right. They did call it Goldine. I just... why?
We were just amused by the name.
Why is that nomenclature there? I don't know. They heard graphene and they're like, I don't know where the graphene should be. I don't know. There are rules to name stuff.
Yeah, graphite. It's ite. So I don't know, how did graphite come about? Yeah.
If physicists were naming it, it would have been like super gold or something. It would have been ultra gold. I love that about physics, though. It's all ultra super.
It's all yeah. It keeps it entertaining, right?
Yes,
it keeps it alive. Yeah.
You can whisper me a link. Yeah, I'll put it in chat. I did see that paper, though. They were making claims about reactivity and.
So there's a theory in particle physics called the Eightfold Way, which is inspired by, Buddhism, right? Because there's a eightfold way in Buddhism, right? In religion. So that got a lot of attention in its time back in the 1960s. So having a catchy name helps for sure. Yeah,
branding.
For sure. Branding. Yeah. Unfortunately, the guy who did not name it the Eightfold Way didn't get the Nobel Prize. So.
Oh, there it is. 2D gold. Goldine.
Yeah.
Goldine. New 2D form of gold makes graphene look boring. Oof. Them fighting words. Do you feel like modeling Goldine? Is this something you're interested in?
I've seen enough gold in my life with my dad. Not right now. I've not given it some thought, but maybe in the future. You don't know. Yeah. Goldine.
All right, it's 10:28. Are you ready for some NARC?
Sure, I'm ready for it. I'm ready for it. I'm stuck a little bit on this Mario stage. Sure.
All right, ladies and gentlemen. So as is tradition on the stream, I make every single one of my guests play NARC, which is this bargain bin game from the 1980s, written and coded by Nancy Reagan in the War on Drugs. Just kidding. None of that's true. But yeah, NARC is the game we close with every night, and we make our guests run it as fast as possible. Okay. So I'm going to put up a timer.
Remember, it's Nintendo, right?
Nintendo controller.
And B is for the fast.
Yep. And, so B doesn't help you on this one. He only saunters at a very specific pace.
Okay.
So let me get this timer up.
Okay. So in this one, I just press A to go fast or something. Oh.
Yep. So we are going to get some NARC going. All right, Hitesh. So we have a copy of the game in front of me right here. Nice. So I'm going to read the back of the box so you know what you're getting into.
Yeah, absolutely.
All right, NARC. No one had the guts until now. That's the tagline for the game. You are Max Force. Your mission, bust Mr. Big and destroy his dreaded criminal empire. Seize all contraband, stolen money, illegal weapons. Use rocket bombs, high-powered machine guns. Apprehend all suspects. Protect the innocent. Punish the guilty. Stop at nothing.
Oh, wow.
Yeah. So we got a lot of pressure.
That sounds like a very nice career I should have had. Yeah?
I mean, there's still time. Take that, drug lord. Absolutely. We're not just, drinking and talking science. We're winning the war on drugs tonight, ladies and gentlemen.
Absolutely.
So, Hitesh, whenever you're ready, go ahead and press start, and I will start the clock as soon as you hit the ground running. Your goal is to go right and find doors as quickly as possible. There's no advantage in killing any of these individuals.
What if I feel like?
You can do it. It's going to cost you time.
Okay.
Note, which one of your physics colleagues are you most want to beat?
I want to beat Take.
Okay, I'll look up Take.
So I just press the right button, or
basically, and
this is just walking.
And go through the door and go right. Find a key card, and holding A shoots bullets. Tapping A shoots rockets.
But I don't want to kill anyone, right? That was the idea.
There's no advantage in killing them. But if they're shooting you might as well.
Yeah, might as well just take some revenge.
Yep. So grab that red card that's on the ground there.
Okay.
There you go. Go right. Find a door. The doggos become condensed.
Oh my god. Oh, come on, I gotta go to the exit. Come on.
Yeah, so we're gonna have the theoretical high energy particle physicist versus the theoretical condensed matter physicist.
Right.
Put your predictions in now.
Yep.
Speaking of predictions, we didn't choose an outcome. All right, how was it made? Scotch tape or chemical vapor deposition?
Oh yeah. What was the end result of that one?
Tash, what is your answer?
Scotch tape.
Scotch tape.
And
turns
pencil.
out everyone knew that. We had a dark.
My questions are too simple. I'm too nice.
I mean, if you're a science nerd, you have to know that. Right? It's like Scotch tape solving problems.
That's one of those things I would say a hobbyist, right? Could do, but they of course needed a lot more. They did a lot more after that.
Yeah, like you could make it, but then you'd have to do like a TEM measurement.
Absolutely.
Right, absolutely. Through the door.
Okay.
So you talked to Take about the stream?
No, I did not, but I will now. Now that
You saw him on the list, and you're like, I'm gonna beat him. All right. So coming up here, you're gonna shoot these guys wearing black with bullets
I
at
gotta shoot
relatively close range.
Okay.
So not rockets. So hold A.
Okay. Oh, just hold A.
Yep.
Okay.
So hold it. You're gonna hit them at reasonably close range,
Okay.
and one of them is gonna drop this blue key card.
I see.
So they're a little dog. So if you hold both buttons down, you can shoot the dog and make it small. Don't worry, it just turns into a puppy.
But here's the key.
Nope, it's gonna be a blue key card.
Oh, blue key card. Come on, man. Somebody reveal it. Get it to me. Oh, give it to me.
You might want to get closer to them. For some reason, it's hit. Oh, there it is. Blue card. So grab that guy.
Safe and then go.
Find the door. And you're done.
Oh, okay.
All right.
Okay.
So that key card drop is a random number generator.
Okay.
You have like 1 in 8 odds of getting it or something like that.
Oh, I see. Pretty interesting.
All right, if you guys have any last minute questions for Hitesh, we have about a half hour left before he beats NARC and wins the war on drugs. But during that time, you can distract him by asking him really complex physics problems related to condensed matter physics, many electron systems, solving the world's problems one electron at a time.
I like that. I'm going to use that somewhere.
Can't you generate X-rays using duct tape? No, it's actually Scotch tape as well. Have you seen this paper?
Which one?
It was from like 2010 or something. It might have been earlier than that, but they took Scotch tape and through the mechanoluminescence, basically the mechanical force of shearing the adhesive, you can actually generate X-rays.
Oh, wow.
And so what they did is they generated a pulling stream that actually generated enough X-rays to get an X-ray of a finger.
Oh,
so
wow.
they had a detection plate behind it, and they just blasted the hell out of it.
my
So
God.
yeah, you can generate X-rays using Scotch tape.
That is amazing. That is simply amazing.
Yeah, no, would have thought that would have been something, man. Oh no, Huggy Bear, I did not walk him through the car. I mean, it doesn't save you much time at the start. I'll give him the next car. I apologize.
Do I have is he a buddy?
No, keep going right. He's wearing blue, but he's not.
What is that? Oh, what did I get there?
Keep going. Yeah, those are bombs.
Bombs, oh my god. It's like a key or something.
Oh yeah, here's an MIT Tech article on it. If you guys are interested in making Scotch tape,
Very
making
interesting. I'm
X-rays with
definitely going
Scotch
to look
tape.
at. What do I do now?
Jump over it, so tap B.
Tap B. Tap B. Tap B. Oh, I see.
Oh man, I was distracted by Scotch tape discussions.
It's okay. It's okay. I'm not going to beat Take. I know it. It's okay.
So Hitesh, right before the stream, asked me, what kind of questions will the audience ask? And I said, I have no idea. And now you know why.
This is fun.
you know why.
No, I really like it. I like inquisitive, curious audience. It's really awesome.
Yeah, but you guys have the brain of a physicist right in front of you, so whatever questions you have, ask them.
Tap B, yeah?
Or casual, or you can go under the bottom. Yep, tap B, lighter than what you're doing. There you go.
I see.
Yep. You have 7 frames, so it's 60 hertz. So 60 frames per second, so you have like 7/10 of a second.
Right. Ooh. Oh my god, come on,
Keep
get
going
him.
right.
Get him.
What did Take?
What's his timing?
Do you really want to know, or do you want to know after?
No. Later.
I'll know the number.
Yeah. It's okay, it's just for fun. Oh, doggy.
Yeah, keep going.
Leave me, doggy.
Keep going. You're good.
Oh my god, these dogs are violent.
Those are drug dogs.
Oh my god. And this guy is like taking a stroll in the park or something. It's getting shot. It's enough. Okay, I will not. It's
So Take was a bit of a gamer.
Do I get into the car?
Jump in the car. So B, press B.
B. Okay. Tap.
Tap B, less hard. Yep, there you go. Stay on the bottom. Then go up. Keep going right. Keep going up. And you'll hit a wall. And then you keep going.
Okay.
NARC, drink and drive, absolutely. Oh, Lori has redeemed check. Take a drink. So cheers, Hitesh.
Cheers,
Lori.
Cheers.
Hopefully I have something in hand to drink too, because
Lori.
Oh god, graduate admissions is over, at least formally as of April 15th.
Yeah.
Hopefully anyone in the chat that was looking for a grad program, hopefully you got in the grad program of your choice.
Right.
If not, go somewhere you're going to be successful.
Now I feel I have to meet Laurie in person. Yeah.
Yeah, you want to? So Lori actually works remotely. So she comes in for visitation weekends as well as orientation. So,
I see.
But yeah, if you want to swing by, man, what would that be? August 20 down.
Oh God.
Oh,
What do I do?
oh, Lori will be on campus later this month. So tap B, get over the top of it. There you go.
Yeah. Okay. Oh, God.
All right, walk right.
Walk.
Oh, the award ceremony. So she'll be around May 2nd and May 3rd.
Oh, I see.
Because we have hooding on that day. So that's fun. Take's time was 28 minutes and 19 seconds. So go to the bottom and just walk right.
And then, just go around it.
Misadventures. So judgmental. Losing the car there is going to cost you some time, but if you can make it up, what I would do right now is practice jump and then rocket.
Okay, jump
so just keep pressing right.
Yeah.
Just hold right, don't lose right.
Yeah.
But tap B, and then when you're in the A, tap A, or in the air, tap A.
Okay.
Yep, that was close.
Okay.
So we'll practice for the final boss.
Doggies.
The final boss is the great equalizer, and so Adam Dewan from psychology, he got to the final boss basically on his first try, and he has the fastest time of anyone on stream. So so tap B,
yeah,
and then A on the way down.
Yeah, okay. So tap B and A.
So yeah, if you're getting bullets, you're pressing it too hard or too long.
Okay.
So tap B.
Yeah, now I tap B.
Yep.
Sorry.
Yep. So hold your right arrow.
Yeah, tap B.
Yep.
Yeah, right and tap B, right?
Yep. And that'll jump. It's a little lighter,
B.
Softer. It's just a little too wide. There you go.
I see.
So tap B and then tap A, but you're going through that door.
First,
so you're good.
Okay.
Oh God! You feel the pressure?
I feel.
No one actually cares about this game. We're 3 hours into this. So.
Long walk.
Go right.
Oh, go right.
Yep, you'll find a door at the end.
Oh God.
Yeah, last door.
Yeah. Oh God.
So yeah,
this is clown, man.
This is such an absurd thing, but I'm so glad. Like you have 50 colleagues across a dozen different departments that have played NARC against you. So, so this is part of your team decision. Oh man,
walk of shame.
So you're gonna go to the last door on the right.
Oh, what is
that door right there?
Clowns
with knives. You know, they're on drugs.
Crazy, man.
Oh,
you might know the Batman.
So those of us that went to high school in the U.S., so you're going to grab that card, go through the door and turn left, and go to that safe. Nope, not that door. That left. That one right there. Yep.
Go.
Perfect.
Oh God.
But yeah, we had this program called Dare, and it was Dare to what was it? Dare to say no to drugs or something like that. But it was related to this 1980s drug scare thing.
Oh God.
And it's been shown like through research that Dare actually increased drug use. So it didn't actually hinder drug use at all. And the reason is because they made every single drug seem scarier. You're gonna go left. Yep. And what you're going to do is shoot the green guys with bullets. So when they're close range, just hold A, and you'll get.
I got it.
Yep. And so they have to be relatively close to you for some reason.
I need the key from them.
Yep, the green guy. Yep.
Oh, go.
So that's rockets. You want bullets.
Okay,
so hold it longer. So that was money. One of them will drop a green card.
Come on, give me the card, man.
There it is. Done.
Go. Come on.
Drug abuse resistance education is what DARE stand for, according to Mattis and to Robert. All right, ladies and gentlemen, we're winding down. If you guys have any last-minute questions on condensed matter physics, about many electron systems, about magnetism, about superconductivity, about spin liquids. We haven't talked about spin liquids.
Yeah.
We did a little bit at the start, but why are spin liquids weird and why are they interesting?
So, yeah, actually, that's a great question. So, we actually understand a lot about magnetism in general. Like, you take your refrigerator magnet, it's what we call a ferromagnet, where all the spins are pointing in one direction, right? It's polarized, all the spins are pointing in one direction, that they stick to your refrigerator. But actually, people for a long time didn't know that there's something called an anti-ferromagnet, which is not a ferromagnet.
Oh, keep going.
And it has actually spins that are anti-aligned with respect to each other, right? So for a long time, people didn't think that something like this could exist.
Door.
And
go right.
And so antiferromagnets actually turn out to be tremendously useful as well for all sorts of applications including, as I said, the high temperature superconductors are actually the parent compounds are antiferromagnets, which when you what we call dope them, which means you chemically substitute certain species, you actually get superconductivity. So that was ferromagnetism and antiferromagnetism, but it turns out that there are other forms of magnetism that don't belong to either category. So you need to kill these people?
Right there, card.
Yeah, okay.
You got it. Yep. The next 3 cards you have,
I see.
or the next 2 cards.
So it turns out, yeah, so I think that's the question, what's suspended? Yeah, so now you can say when spins order, the electron spins, they order in some...
Keep going.
Right?
Keep going.
Yeah, okay. I got
I'll keep you on.
Yeah. When spins order in a certain pattern, that's what happens in a ferromagnet or antiferromagnet. But in a liquid, you don't have any particular ordering pattern. That's the important thing. And it turns out that the excitations of this quantum spin liquid, this liquid of electrons, it's not a liquid of atoms because that's the one that we see in everyday life, but this liquid of electrons.
So it's a solid material, but the electrons are like liquid.
But the electrons basically act like a liquid. Oh,
yep.
I need the blue card. And it is this liquid, these excitations of this liquid harbor what we call anions. These are like not fermions, not bosons. They are fractional quasi-particles, and we touched upon a little bit on fractionalization a little earlier, that can you really split an electron? Well, you cannot split an electron, but you can have collection of many electrons that act like half an electron or 1/3 of an electron. And it is these quasi-particles, these anions. My God, what's happening here?
You might want to shoot the dogs.
I want to shoot the dogs.
Yep. So hold both buttons down.
Yeah.
There you go. Shoot all the dogs.
Oh God!
Both buttons.
I'm going to jump over the dog.
Okay, so hold both buttons.
Yeah. Okay.
All right. So you're going to want to shoot everyone on screen, and what's going to happen is a guy in a wheelchair will show up, and you have to shoot him with a rocket.
God, what is going on?
Hold both buttons.
Okay.
Oh, there you go. There's the guy with the rocket. You got to shoot him with rockets. So tap A.
Tap A. Tap A.
Yep. So you don't have to jump. You just tap A.
Yeah, tap A. Tap A.
And
where's the guy going?
He'll come back as soon as you kill everyone on screen. He'll come back. So there you go. There you go. Well, that's 1. So you have to hit him 3 times and shoot the dog. You can swap both buttons or use a rocket. That'll do it.
Okay. Yeah.
You having fun yet?
It's very simple.
Oh, Taki's going to be so disappointed if he judged accordingly. So shoot the guys on screen. He'll come back.
Come on, man. Come on.
A little lighter. There you go.
Okay. Come on.
So kill the guys on screen. He'll come back again.
Okay. Come on.
Yeah, there's weird timing on this boss.
I got to kill this guy also. Oh my God, I'm having a difficult time.
Yep. Oh, there you go. That's number 2. You need one more shot.
One more shot.
And if you want to practice jump rocketing,
yeah, you said
tap
B,
and then in the air you're going to tap A.
Tap B. Oh God. Stop, dog. Stop.
Yeah, might as well kill these guys.
Yeah. So I just bend down and kill them, right?
Yep. Hold both buttons down. Hold both buttons.
That's a bit violent, dog. Come on.
Yeah, exactly. This is the war on drugs.
I go to press both.
This is the America your child is.
Oh my God. Oh yeah. This guy in a wheelchair, I don't feel like killing him, but I got
he's shooting at you though.
Yeah, I know.
All right, kill the guys on screen. He'll come back. All right, if you guys want to distract Hitesh, now is the time. Ask your science questions, the really hard ones. Keep him distracted.
Yeah, quantum spin liquid. Yeah, that's what distracted me.
Take shows up in chat. It's like, I'm going to ruin your day.
It's okay. I can have the slowest time.
All right, we have roughly 15 minutes left. If you guys have a suggestion on who we should raid, preferably science streamers, but we'll raid anyone that you think might be interesting. Put those guys in chat. Looks like there's a few people on science with paleontologizing. Mahoodles, astrobiology, that's fun. But yeah, if you guys have suggestions on who we should raid, let's do it. While Hitesh beats the last of the bosses.
Difficulty with this.
So yeah, shoot the dogs. So press both buttons. Yep. There you go. Okay, now rockets when he comes back on the screen.
Rocket, it's just A, right?
Yep, tapping it.
Just tapping A.
Yep.
Oh, tapping A.
Yep.
Oh, I thought I have to shoot him with bullets.
Yep, so tap A. A little lighter. There you go.
Oh, okay, but I have to shoot these guys.
So that's how they turned 4 buttons into 2. So this was originally an arcade game where you had 4 buttons, but Nintendo controller you only get 2. So they're like press it light, and you get a rocket.
Yeah, I see.
So a little lighter than that.
Okay. I think I need your help in. I need your help in beating these.
You got this one. The next phase is what's going to be the night.
Oh my God! Don't scare me, man! Don't scare me.
You should have watched the video.
I should have. I didn't know what I was signing up for.
Tap it lighter. Kill these guys. He'll come back. Just try it again.
Oh God!
You're pressing it a little too hard. There you go.
This one.
Yep. So yeah, like you don't have to press it all the way.
I need magnetism factoids.
Yeah.
They asked for a magnetism factoid.
Oh, Huggy Beer, you got to pay for your factoids.
Oh yeah. Everything's free. Knowledge is free. No, it's not. God.
Oh, there it is. Huggy Beer paid for a factoid. So,
oh God.
Oh, Tesh, while doing it.
The third one. Come on. I gotta kill you.
Oh, that was close. All right, what's your factoid? Magnetism related.
Yeah, I wrote something very generic, which is how your computer hard disks work. Mm-hmm. They work on read-write principles, but you can ask, how is it reading a 1 or 0, right? And so it's basically using the principles of what is called giant magnetoresistance. Your hard disks are based off everyday magnets. All the reading and writing is done with magnetic technology.
There you go.
Yeah, so that's my factoid. Yeah.
So my advice to you is when pressing the button, don't press it all the way down. You just have to touch it a little bit.
Yeah, this one. Yeah.
Yeah. Even lighter than that.
Lighter than that.
Yeah. There you go.
Oh, I cannot shoot him with bullets, this guy.
Nope. It's got to be a rocket. Oh, that was close. All right, go to the right a little bit. Sorry.
Yeah. No problem.
And yeah, kill the guys on screen, and then you're gonna do it again.
God.
This is the car has no bearing on this.
I want to play Sonic again.
But you don't like the soccer? Huggy Bear's sure you can do it.
Yeah, thank you, Huggy Bear. Thank you, Huggy Bear. I know I can do it, but depends
how much
where.
Unlimited budget.
Oh God.
There you go. All right. Now it's going to dissolve and it'll drop a gold card.
Really did manage to kill him. Oh wow, safe.
Okay, go right.
In the yellow.
Door right there.
Oh, this one.
All right, next boss, what you're going to do is you're going to go to the top of the screen. Yes, this is phase 2.
Oh, man.
Ladies and gentlemen. So you're going to go to the top of the screen, and you're going to jump and shoot a rocket in the air and hit him in the hat.
Jump with the B.
Yep.
And
while you're in the A, press A. Yep.
God,
so go to the top of the screen.
Why don't you do it?
I will if you get too frustrated. Go to the top of the screen.
Go to the top of the screen.
Yep.
Yeah.
And then jump.
Yeah.
So tap B, lighter than that.
Yeah,
and then on the way down, tap A.
Got it.
And so you can go to the right here, run away from him, get some distance.
Yeah.
He's on you.
Oh my God.
Right? Yeah,
this guy. Oh, is this the last stage?
Yeah. Explain this with your physics.
Oh my God.
So go this
Why
way.
is he eating me?
So keep pressing right. Keep pressing right. Hold it right.
Yeah, I'm pressing right. Yeah.
Yep. And you can jump. You can tap jump and get away.
He's not letting me go. Okay, hold on. Okay. Okay, tap, and now I just go left.
Misadventures in Astro. Speaking of storage, did you see the news about storing data at the atomic level in diamonds?
Yes, atomic level in diamond, like NV centers, or yes. So that is actually a very big theme in physics, if I'm understanding you correctly.
So just run right really far.
I'm running all the way.
And then go to the top of the screen. Go all the way up. Yeah. Keep going right.
Yeah.
Top of the screen.
Top of the screen, right.
And then turn around, pause, stop it, and then
B.
Well, you don't have to pause. And then A on the way down. Oh, that was really close. That's exactly what you're going to do. So run away, repeat that over and over.
Okay, got it.
Sorry, nitrogen vacancies and diamond for storing information.
Absolutely. So they are being used as potential qubits, and so there's a group at Harvard doing that. In fact, we had some people who interviewed. Yeah, I understand. I need to go, but
yep, go the other way, get some distance. It's the perfect way to close the dice.
Okay.
This is the perfect.
He just needs one shot to die?
Yep, just to the hat. Well, that's phase one.
God.
So go to the top.
So
Tap it a little lighter.
Oh, God.
Yep. Oh, that was close. All right.
Oh, God.
Yep. So get some distance. Try it again.
Okay.
Breaking the diffraction limit, pretty neat. In terms of the density, I guess the density on nitrogen vacancy, can they control that now?
I believe so. There were some talks that I heard where they could implant this vacancy at a very desired location.
Wow.
But whether you can make multiple qubits out of it, or are they just using it like as a single qubit, this part actually I'm not familiar with. Like, how can you entangle? Because that's an important part. Well, this guy's entangled me.
Go to the top of the screen.
Yeah, I'll just go up to the top.
It's just easier because then his tongue's don't
Yeah, I understand. It's tongue. What is spilling out, this guy?
tongue.
Ah.
All right, you can stop there.
Now
turn around.
tap B and shoot.
Yep, that was
Tap
close.
B and shoot.
Yep.
But this is I have to shoot it on the way
a
down.
little lighter on the bullet. So if you get a bullet, it means you pressed A too long.
Yeah, I pressed A too long.
Yep.
Oh God, 22 minutes, and then that game ends after that.
Yeah, you kill this guy and you're done.
And I'm done. Okay, so I'm 6 minutes. I have 6 minutes to do this to beat Take.
Yep.
Oh God.
Yep.
No.
Press A a little lighter and you'll.
Yeah. I'm trying, but I.
No, it's not true. This is the great equalizer. And Adam Dewan somehow got this right away.
Can I just shoot this guy in his face?
I'll give you. Speaking of entanglement, entanglement is destroyed when observing it. Correct?
Yeah, when your wave function collapses, is our understanding. Yes, entanglement can be destroyed. It depends on what kind of observation you make. But yes, typically observations, measurement, the process of measurement, destroys entanglement. Typically speaking.
All right, so you're far enough away. Turn around, stand still, tap B, tap A.
Tap B.
Oh, that was close. Yep, you need a rocket to come out instead of a bullet. Get some distance, try it again.
Yeah, okay. Oh man, this tongue guy. What do you call this guy?
So his name is Mr. Big. This is Mr.
Big International.
So I'll read you the quote again so you know the context.
Yeah.
You are Max Force. Your mission: bust Mr. Big and destroy his criminal empire.
Which jump
somehow his drug agency has come up with a head on a robotic mount that shoots tongues. I don't know.
That sounds very good.
That was pretty close. Yep. So a little lighter on the rocket.
Yeah, a little lighter. So it's a timing thing, or is when I'm pressing it too hard?
I had a vision of using entanglement as an instantaneous communication, but it being destroyed is a non-starter. I mean, that's something people are trying to do, right? You entangle two particles or photons or electrons, and you separate them by a given distance. And if you measure one, you affect the other.
Absolutely right.
That's theoretically faster than light communication.
Well, that's what bothered Einstein in the 1930s. But the thing is that the information was always known, right, in advance, because how you prepared the state. So it's not like you're communicating any new information. It was already known how the state was prepared. So that's the sort of resolution that people give to this paradox, like, oh, how did this information travel faster than light? Well, I hope I can travel faster than this guy first.
Communication misadventure. The design meetings for this game must have been wild. Huggy Beer, you think someone had a meeting about this game? No, this was the golden age of video game making, when it was like one dude was in charge of this level. Like that's how they did it back then.
I'm losing all the advantage I had.
So run away, stay at the top. You'll stay
at the top.
It's the same thing.
Oh God.
Non-locality, spooky action. Sometimes that's physics has the sexiest name.
Yeah, I agree.
Action,
they're very good at. I agree.
I mean, it's ultra. It's spooky. It's something.
Spooky action at a distance is what Einstein called it.
Yeah.
Right.
Or Schrodinger's cat. Like, how fun is that? All right, so you can stop there. And turn around.
Yeah, and B, and then.
Yep.
Well, why is he punching?
So you're pressing it a little too long.
I see.
Oh, there it is. Yep. So if you see his arm come out and you see a bullet come out, you pressed it a little bit too long.
I see.
The audience is pulling for you. We got this.
You can do it. Okay, thank you. Thank you, everyone. Thank you for your patience.
This is the gameplay they come for. So a little too long.
Okay,
Yep.
run
So
away.
press it lighter. Don't press the button as hard.
Okay.
Very gentle. Yeah, that was pretty close. There we go. So a little later on the rocket, and that'd be a headshot. And that is part one. The next ones are easier. This is the hardest part by far. This is the one people struggle with.
And there's a stage after this?
Yeah.
Oh,
well, there's a part of him you shoot him in the face with rockets, and then you have to shoot him with bullets, and then he's done. But this is the hard one. This is the
Mr.
major
Big
hurdle.
International.
In fact, I could make a compilation of like 50 guests spending like 3 hours on this.
Oh my god. Oh my god. The music
No worries.
is a bit tacky also.
Yeah. All right, you're good.
But
Yeah.
my rockets are going a bit too high.
Yep, so you have to press it a little later on the way down. You got it, you're so close. All right, but if anyone has last minute questions for Hitesh while he struggles with Mr. Big and Final Boss and War on Drugs, ask your questions now. He's going to answer them, and we'll figure out somebody to raid. If you guys have suggestions, let's do that right after this. Stick around, and we will raid some educational streamer.
Happy
Like
accident.
Mahoodles is
Well,
on for astrobiology, which is a fun one that we regularly raid. Nerduino is on. Am I not following Nerduino? Oh, there he is. Just came on.
Arduino. Oh, interesting.
Yeah, just various different science streamers. So
Oh,
across
nice. Interesting.
astrophysics, a couple mathematicians, chemistry. There's actually a pretty lively educational streaming cohort on Twitch. If you're frustrated, I can help out with this phase. If you're beyond rage at this point, I'm happy to intervene.
One last minute, and if I cannot, then I want to beat this guy's face. I want to beat this guy.
It takes one lucky shot, not even
one-
lucky, just one shot to hit the hat,
Oh God, God, God.
and then from there it gets much easier.
Oh God. Okay, maybe I'm gonna give up at this point. Do you want to take over?
Yeah, I can.
Sorry about that. I'm struggling.
So this is one of the games that I'm really good at.
Okay. And I'm gonna read the Twitch in the meanwhile. You can do it. Okay. What was the thing about physics and depression? What was that? Where did that come from?
Nerduino. All right, so here's your next.
Oh
phase.
wow, Ken.
So you'll press start, and what you're going to do is you're going to walk back and forth between these black lines, and you're going to go back and you're going to shoot bullets at them. So you're going to hold A.
we
on
just
this.
see.
Yep. So you're going to walk between here, turn back, hold A, walk away, get some distance,
I see.
and stay between here, and you're going to like move up and down while you
Yes, so
shoot.
that
him. Yep. Move up and down a little bit. It's like you can only shoot him when his head comes down.
Oh,
It's kind of
I
dumb.
see.
All right. Ooze Goober is a spectacular name. Thank you. I'm still curious how magnetic force radiates. Ferro is a combination of aligned spins, but how is that force transmitted? How is magnetism, like there's not a packet of, it's not a graviton or a photon. It's just magnetic field.
That's right.
How do you
And
rationalize that?
that's right. So that is a great question. I mean, then that applies also for electric field. Do you want to try to help me with this one?
Give it a try.
Okay,
Walk a certain distance and you're gonna shoot bullets at
Hold
them.
on. Okay, I'll just go. Yeah, so the whole idea of fields is something that emerged in the 1800s. People had no idea how to
Bullets, hold it down. Not tap, hold it.
hold it with the
Yeah,
A.
yeah.
Okay,
Bullets right there. Yep. And you're gonna move up and down while you're shooting at them, and one of them is gonna hit.
God.
Yep. So turn around, shoot, and then move up and down a little bit. Yep. Eventually,
But I have
it's
to
gonna-
hit him in the
Yeah, it's gonna be a very specific spot you have to hit them on.
Oh God.
So move a little bit up and down, and eventually, it's a weird timing thing. It's basically when his head comes down is when
Yeah.
you can shoot him.
But his head, I got to jump and shoot him or
No, you just walk and shoot him.
Just walk and shoot him. Oh my God.
This is programming in the 80s. Yep, move up a little
I'm
bit.
just
So hold
moving on.
bullets. Yep. So you're gonna hold A.
Yeah.
There you go. And if it makes you feel any better, every one of my guests has something. I
should have seen the end of the video rather than
3 hours. You have to totally.
Oh
worth
god!
it.
How many times has this guy died?
On our stream, at least 50 times. How many guests do I have? Let me see the scoreboard here.
Oh god!
So I have
and that
62.
too.
Roughly, 68 of my
60.
guests have played this.
Okay.
They have all beaten it eventually, either with a little help or not.
Okay. I just gotta.
Nice to meet you both. I'm M52. I studied bioengineering in electronics in the 90s. Engineering. Love retro games. Well, you're in the right spot because most of my guests pick retro games.
But I didn't answer the question about fields. Okay.
No, you didn't. You're focusing.
Yeah, I'm focusing on killing.
Let's close with fields while you shoot some bullets.
Oh, come on.
Yep, move up and down just a little bit.
Oh god.
And again, if you get annoyed, I can intervene on the next
I'm
two.
okay. But yeah, maybe in the interest of time, maybe you should do it.
It's up to you. How soon do you want to get home tonight?
Exactly.
Is your wife gonna be angry? I was playing video games all night. It's an excellent excuse.
Having a difficult time doing this.
Yeah.
Come on, shoot! Put your head down. Oh.
Yep. And so you just have to move up and down a little. Like if you're perfectly aligned, it doesn't work.
Yeah.
So when he's going down, you have to be like up or down slightly.
I see.
It's really.
Do you want to take over? Sorry about that.
So,
yeah, regarding fields, I think that's a good question.
right, so here's what I'd advise. So it's like timing. So his head comes down.
Yeah.
See that?
Oh, wow.
The way I do this.
But his head, I feel, doesn't come down all the way down.
No,
right?
exactly. The alignment is bad, which is why you have to do the up and down thing.
I see. Man, you're gonna. Oh, what was that?
So that's one of his vertebrae. So you have to do that 3 more times.
Oh, you're not gonna hit him in the skull. You're gonna hit him. Oh,
That's it. Yep. So there it is. So it's all yours. You get to close out the level, go to the right. You're going to find a door. Then you have another level where you can collect gold, but you don't want to. Find the exit, be done. Fun factoid, I'm the former world record speedrunner in this game. So the record, I had the record at 9 minutes and 7 seconds.
Oh my god.
I forced all my guests to play it. But congratulations, you did it. You beat Mr. Big. Now you just have to go through the final level. So go to the right. You don't need gold.
I don't need gold.
Welcome to NARC PTSD.
Well, you took 9 minutes to do this game?
Yeah, 9 minutes and 7 seconds is the world record.
Oh my.
Or no, 9 minutes and 4 seconds is the current world record. There you go.
Amazing, man. Can I have newfound respect for you, man?
Oh, I have a YouTube tutorial for next time you're on. Go over
This is the next solar eclipse.
2044. Mark your calendars, ladies and gentlemen.
Yes.
Hitesh is going to be on.
Yes.
We're going to play NARC instead of looking at the
And your
sun.
question about fields will answer it.
All right, so put your initials in. It doesn't matter. It won't save your initials. But if you like the old arcade play,
It's fine.
Ken accidentally inserted his time and pretended it was still the record. Yes. I can't let go of my record. Someday I'll have to come back and try to fight for the new record.
HC, but okay, that's fine. Yeah, it's not a big deal.
Good enough.
Start, what do I do? Press A.
Go down into end.
Oh, and okay.
All right, Hitesh. That's it. The evening's over. You played some Mario, played some Sonic, a little bit of Street Fighter. You played some NARC. You won the war on drugs. We talked a little bit about science as well. Hitesh, any parting words for the audience?
Stay curious, stay hungry for science, and enjoy gaming. And have a good night.
Yeah. That's perfect. Hitesh, it's a pleasure. Thank you for joining me.
Thank you for having me. Yeah.
I sent an email to my guest saying, do you want to play video games and talk some science? And he said yes. You may regret it now after the NARC adventure, but it's been a lot of fun, especially we appreciate you guys stopping by, asking really fun questions. It's you take us all over the place and we really enjoy the conversations. So yeah, thank you for joining us tonight. In 2 weeks, we'll have our next guest. Our guest is Dr. Sachin Shanbag. He's from from scientific computing, but he does multiscalar model of natural and synthetic materials. And so modeling, again, we have a theoretician on that's modeling complex systems, but not on the electron level, but more on the bulk properties and materials properties, where you start using Monte Carlo simulations and Bayesian statistics and things like that. So yeah, all levels of modeling are necessary. So Sachin will be on in 2 weeks. Swing by for that. But yeah, it's been a pleasure. Thank you all for joining us. So hopefully we'll see you guys in another couple weeks. Until then.